Well, hello everybody. Back again with another show. And as you can tell, I'm not oi-oing it tonight. I'm not oi-oing it. I'm not quite 100%. I mean, a little bit of discomfort with this stomach problem that I've got. So I'm not too sure what's going on, but it's really quite uncomfortable. I was actually going to go and do an observation this evening. We have no swell this evening, and it was low tide at around just after 9 o'clock thereabouts. And I was going to go down and try and film the lighthouse from around about St Anne's, and that would have been a long way. But to be honest, I couldn't make it, just not well enough. So I thought I'll do a show instead. So if you caught the 2 hour extra stream that I put out before, that was a premiere, you'll note that I didn't have a lot of interaction with that because I just left the after show recording after I went to bed last night. I went to bed about 2:30 in the morning and left that show recording, and the guys gave us another couple of hours, so it was really interesting. I think we had about 50 people watching, so maybe go and take a look. If once you finish this, it'll pass 2 hours of your time, and yeah, it was quite a decent charge. Like, I enjoyed listening back to that. So anyway, so let's do a few shout outs from the people who are in. So okay, so we've got Brandon Toy and Plain Truth, oi oi. Colin Dresser, nice to see you in, mate. Amanda Young, Paul Keeling, Good Servant, Brian Shuker. Brian, if I'm feeling up to it tomorrow night, do you fancy doing an observation? Maybe you can get to Southport tomorrow. If so, I'll get in touch with you. Just give us a thumbs up, and we'll have a discuss on Skype about it and see if we can get something organised. SE, nice to see you in. Who else have we got? Seek and Find and YouTube. Always there. Brandon Toy. SE, nice to see you in. Rune Thornson and Jimbo. Paul Keelan says the Isle of Man was visible with the Eye and Barrow Lighthouse. Don't wind me up, mate. I was I swear I was going to go and do the observation tonight, because everything was perfect for it. No, very little wind, no swell. I mean, the swell is almost non-existent. So low tide. I mean, there's no better chance of going. And the reason I say low tide is because you don't have the pooling effect, because it's so shallow where we live. It ends up more like a lake on low tide. So low tide, it's very, the water table is very low across vast stretches where we live. When the tide comes in, because it's like a 9 meter turnaround, so you're talking 30 feet or so of turnaround in water height. So that extra height does create more issues, believe it or not, just because of the topography of the land. But when the tide goes out, and sure, yeah, you can see further when the tide goes out, because in this area you've got it's much shallower, so it doesn't get that cresting of the waves, and it was just perfect for tonight. So Paul Keeling, okay, so you say, do us a favour, mate. I know roughly where you live. It's possible that you could perhaps go down there and see if you can see the lighthouse off the beach. I don't know if you're going to try and do that. It was just on the South Pier. Oh, really? So you saw it from South Pier, the lighthouse. That's amazing. Right, okay. Well, that's just made me feel a whole lot better. So, what can I say? Brandon C, nice to see you in. Who else? We got Alexander Lightwater. Let's see if anybody's popped in Discord at the moment. Let's have a look. See. Let's see. Yes, we do. Let's undeafen myself and say hello to the real Bob Dole. How's it going, my friend?
Hello. Going
Hello.
all right, I think.
And Paige, how is it going, my friend? Yeah, Randy, yeah, it's going good, mate. It's going good, yeah. So, yeah, I mean, Bob, you asked me a question. I did respond to it in your Discord, but what was the problem with the stream that you had before last?
Oh, it wasn't a problem. I was just I was wondering if you had seen the whole thing, because if you watched it all the way till the end, right near the end, we talked about it a little bit last night. right near the end, they were talking about this Foucault's pendulum or whatever it's called, and the way what they were saying to me seemed to indicate that it was not designed uh, with the concept of proving Earth's rotation in mind. But the link that I was given, I went there, and like within the first sentence of the main article, it just comes out and says that that's exactly what it was designed for. But even if I'm misunderstanding that sentence, it goes on. Whenever you get to the mechanics of it being explained, it relies on things that are like clearly theoretical and not proven to be reality.
I see. Right. Okay. Carlos is here, and we've got Brandon Toy. How are you both doing? Let's do your mic there, Carlos. Let's check how you're doing. Carlos, can you say hello again? Because you sounded pretty low then.
I'm doing great.
I'll put your mic up a little bit. There we go. Right, okay. Brandon.
No.
Hey, Ranty.
Hey, how's it going?
Not bad. Hey, I can't stick around on voice. I got some family now, but I did want to tell you that I left that tank up. It's still up, and I took some more pictures today. It appears that whatever undissolved granules were on the bottom, the reason it looked white on the bottom of the tank, those have fully dissolved, and there's no difference in the density gradient, no visible difference, and no visible difference in the effect. So that criticism that we've had from a couple different people makes no difference whatsoever. Just FYI.
Perfect. Well, I suspected that anyway. It's just that they'll cling on to anything to try and discredit something that goes against their beliefs. Which leads me on to the point today. You asked me, did I see Jose's show today? I saw parts of it. I saw the part where B-Ball came in and he was saying, "You can trust me. It's fine. I don't lie. You can trust me. Look, here's the video. Here's the thing." He didn't provide any more proof. Didn't show where he was. Didn't show his observer height. Nothing. It's just we've got to believe him. We've got to believe him. Yeah. That's all I got from that.
Well, those guys' standards is as long as it's plausible and it aligns with the globe, then they really don't ask that many more questions or scrutinize it. So that's good enough for them.
Yeah, and they just totally ignore the waves and the shoaling effect that's in that location. They just completely ignore that, and they dismiss it like, "Oh, shoaling, yeah, 200-foot waves." And when they start talking about 200-foot waves, it just at that point you just know that you're talking to complete retards.
Yeah, and just so you guys know, I'm pulling together a video with all my a few more details about that fish tank experiment, and I've started a new one as well. I've gotten some pebbles to simulate a ground, and I've gotten some different objects to simulate some different things, such as a bridge going from the foreground to the background. We'll see if there's any difference.
Yeah, I was thinking of recreating that same one, for Soundley's bridge, because I've got like a 3-foot long tank. And I was thinking of doing that too. When you actually said you were thinking of recreating the bridge, I thought, oh, he's stolen my idea, because that's what I wanted to do. But awesome, if you're doing it, I mean, great stuff.
It might be better in yours because it's because of the 3-foot distance.
Yeah, well,
I wouldn't be surprised if it, would turn out. But I did mess around, and I plopped a couple things in there that were long last night, and you did see how it kind of disappeared in the back and didn't disappear in the front. So there's that effect on something long. But we'll see what it looks like when I do it properly.
Okay, right. Well, you robot.
But yeah, I'm still pulling the video together. I should have it out either. I'm on the road right now, and my brother's down and stuff. But I just wanted to let you know that.
Okay, no worries, mate. Well, you take care. You're roboting a little bit at the minute, but we've got everything that you said, so.
Okay, cool. See you guys.
All right, take care, mate. Joined by Left Lane. How's it going, Left Lane?
I'm doing good, Ranty. How are you?
Oh, yeah. Been better, but it is what it is, Saturday night, what are you guys doing? Oh, is it night for you, though?
I just went back to work. Got my big truck headed to Phoenix.
Cool. So you're on the drive then. Everyone seems. Do you know how many people join this on the drive? It's really weird. You've got Travis, you're driving. You've got Brandon that was driving. Seems like that's the place to call in from when you're actually driving.
You've got a lot of time to listen, and it passes the time a lot better.
Yeah, I get that. I hear people say that. Paige, we haven't heard from you. How are you doing? You need to come off mute. There you go.
Yeah, I probably won't say much. I haven't got headphones in at the moment. I've only just gotten up, so I'm just having a cuppa and some brekkie, and then I'll join in about half an hour or so.
No worries, no worries. Bob, what keeps happening? You keep dropping in and out. You having issues with your mic there?
Yeah, he started to sound really robot-y, and then you did, and so I decided to go ahead and try and fix it. Now it seems better.
Ah, right, okay. No worries, no worries. Right, so, did any of you guys see what happened, what transpired today on Jose's?
I did not.
Okay, so, nobody? Carlos, were you there? I guess not. I guess he wasn't there. Well, we heard a lot of doubling down. I need to get the video up actually, because there is a part on that. Whilst I'm doing that, I'll just try and get to the part that I'm going to look for. So let me get the Jose's stream. Okay, so this would have been 2 hours ago. So is Brian around? Is Brian Leak around? Anyone seen him around? I know he was on Jose's. Right, there we go. So, anyway, so I'll share this screen anyway. You can have a little look. Right, okay, so you want me to share the screen so you guys can see?
Sure.
Okay. I'll do that.
Here,
okay,
that boat
so
came later on in the day. So in my original video, that boat's not there. But about right here in the center, that's where my location was, next to that little umbrella right there.
right, there we go, that's better. I had no control over what was happening then. I kept pressing stop and start, and it just carried on. It's carried on. So let's bring this.
So this is the actual elevation, which I never claimed.
That started again. So he says that this was his actual elevation that he never claimed. I don't believe I actually heard him in the video claim specifically that it was 8 feet. But if you go to the end of the video, it's interesting. You've got Mick West, not Mick West. Is it Jesse? Oh, I can't think who it is now. I'm going to have to go to his video and find it myself now. So there is another guy that agrees with his observation, and he puts the observation height in at 8 feet. Would you believe it? So the fact, and also he uses another observation and gives that at 8 feet. He also does a side-by-side comparison showing the two same locations, and if you want to be arsey about it and say specifically he did not say his exact height, but no, there was enough in there for you know, the average person to believe that he was giving an 8 feet observation height. So here we go. So right at the end part. So this is Walter Bislin, my bad.
With his code calculator.
So he goes on to say that Walter Bislin agreed with his observation, and let's see what he says here, because he's typed it out. Here we go. From an 8 foot elevation, looking tangential over the horizon. So a big part of the line of sight on the globe model is well below 8 feet, where refraction is the strongest.
Looks like it says it again, or even before that, up further. So it says it more than once, even.
Yeah, I'm pretty sure he does. And
For further
the fact that he hasn't actually specifically said that, but then he said that Walter Bislin validates his observation. Just have a listen. This is when I'm talking about be honest with stuff. Be honest with stuff. You've just heard him on Jose say he never specifically mentioned observer height, but it says it in the video. So here we go. Play it again.
Peace. Also, I want to give a special shout out to Mr. Walter Bislin for further confirming my observation with his curve calculator.
There we go. And there's plenty of other times in the video that, I mean, this like for like image that he posts, this is his image, this is somebody else's image, and you know, this is BM Thurballs, this is his, and you know, it's all to lead you to believe that he was at an observation height of around about 8 feet. So yeah, it's just lies upon lies. He doubles down throughout Jose's stream. And basically he shows his entire video. And what do you know, in his entire video, he doesn't do a pan around. But one thing he does actually do, which is what I picked up on yesterday, is he takes a screenshot of that monster wave that's curling over itself on the shelf, basically. And hopefully he takes a screenshot here. There we go. Do you see this huge wave here that runs through the whole image at the back? That is the Shoaling effect. Let me just pause that. I think he takes a screenshot of it at some point. Sure he does. But I already showed that yesterday. I mean, there you go. Look at this. Look at that monster wave that's coming over the shelf. It's just ridiculous. Let me show it you on this one, actually, probably be better. I don't know what's going on with my PC. It seems to be very sluggish right now. So he was standing up and he does a pan around. There we go.
I pointed my camera in roughly the same direction.
There we go. And he's just, so it's at 35 seconds. There we go. Can you see that monster wave that's breaking over here? I mean, guys, can you see that? Running the whole stretch.
I see it, yeah.
Right, now that isn't flat water, and that isn't the hump.
No.
Right, that isn't flat water, that isn't your normal everyday wave. That isn't a normal everyday wave. And roughly about... And that isn't the hump. Right, I can hear you there, Paige. That isn't your normal everyday wave. And
Paige, your sound is coming through on your microphone, so we're hearing him again through you or something, I think.
Okay. There we go. I'll just put you on server mute for just a minute there, Paige, just so you put your earphones in. But yeah, I mean, this is where the breaking over that shelf, this is where the shoaling effect happens. And the fact that they're just ignoring this, it's like there's a huge wall of water in your observational between you and the target that you're trying to observe in the distance. And I don't know if you've ever thought about this, Bob Dole, but if you're on a globe and you have to look over a wave, that is incrementally worse than for a flat Earth, because not only are you then looking up and over the wave, but at the same time the Earth is curving away and dropping away from you at the same time, so your lines of sight are getting further apart. You know, so anytime you have to look over a wave, it's demonstrably more dramatic for a globe Earth than it is for a flat Earth. And it's obvious. I mean, you can see, I mean, you only have to look at this one image, and for them to just exclude this effect that is very obviously there. He must know that he's there. He must know, he must see this water rising up in front of him. Anyone that's gone to Hawaii sees this same effect, and just ignore that is... Anyway, I've got some some links to put into... Is it CGI?
It would be a bit like you waiting until a lake is drained and then shooting your camera across and saying, see how much I can see, it must be flat.
It's ridiculous, it really is. Let me just unmute that. Right, so I'm just unmuted that page, right. Okay, so I'm going to put a couple of links in the chat. So this is for the audience, right. This is talking about what happens with different types of waves. You got the main waves we're looking at are the transitional waves that come in between the deep water and the shallows, and that's where you get most of these effects. You get most of the shoaling, the transitional waves. Look it up. Here's the link. Right, it explains everything. The Globers, for whatever reason, do not want to look at this. They don't want to talk about shoaling and the effect that has. And I'm going to include another link, and pop it in the chat as well, so that you guys can look up both of these, and you can educate yourself on these effects. Once you understand what's going on and what happens in the shorelines, you'll understand what I'm talking about with these observations. I've got to the point now where it just seems, what's the point? I've got loads of videos about this out there for shoaling effect, and they just completely ignore it. They still just completely ignore it. They pretend they live on a ball that's just a flat sphere. So they've got flat water on their model. It's a flat sphere. Think about it. Whenever they give an observer height, it is now a flat sphere, because they go, oh, my observer height was 5 feet, and that's it. No effects of the water. So the water in their minds is flat around that sphere. Yeah?
Yeah.
And
it has to be.
Well, it is. Well, yeah, for them it has to be. Every time you start nipping away at that, though, and you say, well, what about the shoaling effect? What about the waves? What about the wind waves on the day? When you start putting those little things in, suddenly his 5 foot observer height, which wasn't 5 foot observer height, let me tell you, it was much lower than that, but even if we gave him 5 feet, I still calculated at least 8 feet of obstruction in his eye line. That's 16 feet for the total wave height, but you only include the amplitude of that, so it'd be the half. So that's 8 feet to minimum, and he was claiming 5 feet, so he had to be looking over the waves. It's simple as that. And they don't understand that looking over something is going to block off something in the distance, or they do, and they just ignore it, and they pretend that they just
don't care.
They don't care. Yeah, it's just very frustrating. So it's got to the point where I'm just thinking, what's the point of even trying to engage with these people that come in with an observation like that when they're not even willing to discuss the nature of where we live? The nature of where we live is that we have these effects. If you're not going to include them and you're going to exclude them and just say, oh, my observer height was 5 feet, let's do the curve calcs, oh, it matches, and not include anything else, then you're being very disingenuous.
Yeah, absolutely.
You know, it's not worth my time to argue with these people anymore. They know what's going on. My audience knows what's going on. They hear me talking about it quite a lot. And, you know, if they want to click those links and get an understanding of what's going on, and, you know, they'll know. Well, they do know. They can't be that stupid. They just mock it. Ha ha ha, shoaling, they say. And, you know, without actually probably understanding what it is. You know.
Has he said, like, no, that wave isn't there? Has he addressed that at all? The fact that you show the wave on the video, like, it's obvious that it exists. Everybody can see it if they just look. So, like, what is his? Has he answered that at all?
No. The only thing he said to me is, oh, so there's a 200-foot wave between myself and it then? 200-foot wave, is there? You heard him say it today on Jose, a 200-foot wave. I'm like, at this point, you're just being ridiculous. Because if your observer height is 2 or 3 feet, and you have a 2 or 3 foot wave or a 4 foot wave in front of you, you have to look over it, and everything behind that from that point on will be obscured from the bottom up. And it gets more dramatic the higher the waves are. You know, the more you're looking over those waves, the higher the waves are in your foreground, the more waves you're looking over. It's very simple. It doesn't take a genius to understand that. I don't think they want to include it because, like I say, I think it's far worse for the Globers because your line of sight, your eyeball is looking over the wave, so it obviously is in a tangential line, but the ground beneath that is falling away as well. So it's just forever getting further apart. So as soon as you're looking over a wave, you know, anything that you do see is a bonus as far as I'm concerned, especially if you're a Glober. Rodney B says, Ranty, were you able to research the state plane coordinate system? I had hoped the existence of a Cartesian system being used to map the Earth would spark a debate on the panel. I'll tell you what, Rodney B, I haven't had a chance to look at that yet, but I'll tell you what I'll do. I'll organise a show for next week, and we will title it State Plane Coordinate System, and we'll get some debate going on that. How about that? Did you manage to look up that, Bob Dole?
I did not. I've been looking at just a couple of other things, and I've even come up with there's something I want to test, but I haven't quite figured out how to test it yet. When I do, then I'll probably try and set that up. But I looked at the thing that we talked about the other night that they were saying, that Foucault's pendulum. I looked into that a little bit, and from what I can see, it seems like it's fairly bogus, especially being at least partially, if not entirely, based on this some hypothetical or theoretical concepts.
Okay,
Actually not.
we're joined by Brenda. Brenda, can we just check your mic there?
Super is.
Yes, hello, hello, hello.
Okay, you're a bit low. Let me just put you up. Say it again.
Hello, hello, hello.
Yes, that's better. Right. Okay. So Brenda, what do you think? What's your
I don't
take?
think that I don't think that waves have anything to do with the curvature of the Earth.
They don't. That's true. They don't have any effect on the curvature of the Earth. You are absolutely correct in that assumption.
And if my observer height is higher than the waves,
Mm-hmm.
then the waves will never obstruct anything in the distance.
And if your observer height is below the waves,
Sure,
cool. Thank you.
but waves are not usually 6 feet tall, are they?
The shoaling effect, along with the wind-driven waves, absolutely, on quite a lot of occasions, most definitely are. You need to understand what
Right.
you need to understand what swell is, Brenda.
No, so I understand. So if I make an observation, say, not from the beach, but from an elevation above the beach, say 50 feet,
Mhm.
I'm not going to see any effects by shoaling.
It's unlikely, yeah. But when you're down at the beach, anything under, let's say, 10 feet or so, or 15 feet, let's say 15 feet to be absolutely perfect. So anything under 15 feet, you must account for that. You must account for that. You must know your swell reports, the topography of the land that you're filming from. You must know the wind data, and you must get an accurate height above the shoreline to be able to get your calculations done properly. And once you've got all them and you put them in, even though you may be 15 feet above the water at your, at the shoreline, for your calculations, it's quite often that you may have to just put a 7-foot observer height in, because it's likely that there may be 8 foot of obstruction or higher waves than where you are at the shoreline out to sea. So you must deduct that.
So shoaling is something that only happens in the sea, the oceans, right?
Correct.
So if, for example, I'm taking images from, say, a lake or an inland body of water, I'm not going to see shoaling.
No. Unless it's a ginormous lake that has some kind of tidal effects, but it's highly unlikely.
There are no lakes that experience tides. Tides do not
that
affected by lakes.
That experience a tidal effect. There are some big lakes that do have tides on, Brenda.
No, there are none. There are none that I'm aware of. None.
Well, you might be wrong there, Brenda. Right. Okay. So yes, you don't have to account for it generally in lakes, but I am pretty sure that there are. Let me just Google that actually. Are there tides in lakes? There we go. Studies indicate that the Great Lakes spring tide, the largest tide caused by the combination. So yes, so the Great Lakes. So there you go. So the Great Lakes have them. So I was right.
Does Lake Pontchartrain experience tides?
Well, Lake Pontchartrain is actually connected to the ocean, so yes, it does.
But that's just a matter of a few inches or a foot or so, right?
It's still a tide, Brenda.
A few inches
Yeah,
is
but it's
still not zero.
Yeah, but it's still, but it is just a few inches or a foot or so.
That's true. But
So
it's still,
will
you
you
asked me,
admit
did
now
it have a
that
tide?
it does? Yeah. You said they absolutely don't have, and he's shown you that, yeah, it does happen. So you
'Cause
could
it's
at least say,
connected.
okay, Randy, I was wrong. But
I already did. I said it's connected to the ocean, so yes, it does. Yeah, but it's only a few inches, right?
Yeah, I think it goes up to around about a foot. I think is the difference.
So in Lake Pontchartrain images, we can safely ignore tidal effects.
Pretty much, yeah. But why are we discussing Lake Pontchartrain?
Or the Great Salt Lake. We could ignore tidal effects in the Great Salt Lake.
Well, I wouldn't say that because the Great. Let me have a look. I'm sure the tidal effects are quite substantial on there. Let me just. Don't need that one. Let me just. The Great Lake. I'm pretty sure they are quite high. Oh, hang on. No, I might be wrong. Studies indicate that the Great Lakes spring tide, the largest tides caused by a combined forces of sun and moon, is less than 5 centimeters in height. So, although it does have a tide, it is very small.
Right. So then I think that we can safely say that Soundly's images taken across Lake Pontchartrain, or Tim Osmond's pictures taken across the Great Salt Lakes, do not need to take into account shoaling or waves.
Correct. And I never have claimed in any stream, in all the time that I've been doing this, that either Soundly or Tim Osmond has experienced any kind of shoaling effect whatsoever.
That's fantastic. So those images clearly show curvature, obstruction due to curvature.
They show a form of curvature, but not Earth curvature, Brenda. Have you not been following what Brandon Toy's been doing?
There are different types of curvature?
Have you not been? Have you been following what Brandon Toy has been doing?
I'm sorry. I apologize for the sirens if you're hearing those. Did you hear those?
Yes, we did.
Sorry.
yeah.
Sorry about that. I live.
No, that's
I live.
all right.
Okay,
I live
so,
downtown.
So
I live
let
downtown.
Let me ask my question again.
I hope somebody hasn't had an accident out the front of your house.
So over the past couple of weeks, past 2 or 3 weeks, myself and Brandon and Toy have been working upon these fish tanks with different types of gradients inside of the fish tanks, and we've found coincidentally a method to give the same effect as what you see in Lake Pontchartrain. How cool is that?
Pontchartrain isn't refraction.
Why would you say that?
Because the images are of power lines.
And you don't think they are suffering from any forms of refraction at all?
There is some towards the very end of the images, but for most of it, no, it's not refraction.
So the furthest part of the image, i.e. the angular size of those pylons that are in the distance, which are far smaller than the ones in the foreground, those ones that are in the narrowest regions are getting affected by refraction, those ones that just happen to be able to appear to be curved.
You can see curvature along the entire length.
That's perspective, Brenda.
That's not how perspective works. Perspective would produce a straight line, not a curved line.
Not when you include the results that we've been working on as regards refraction, Brenda.
There's no refraction.
There's always refraction, Brenda. In a gradiated system that we live in, with the densest
Yeah.
densest regions being at ground level, at sea level, we get these effects.
In Soundly's images of the power lines, they
They're at
curve.
sea level.
They curve. It's a gently curving line, not a straight line, as predicted by flat Earth. It directly refutes flat Earth.
I think
And it's not due to It's not due to refraction.
Brenda, what is refraction? Can you explain?
Well, let me just answer to Brenda. I think I think that the work that Brandon's doing right now, and the work that I'll be doing this following week, because I'll be doing some similar tests, we should be able to come back with a comparable result to what sound has got. I would be very confident that we could recreate that in the fish tank.
Possibly. However, the pylons, the power line towers, are not in water; they're in the air.
Brenda, is Randy was doing this test? Is it sinking? Are you agree that sinking? The light is bending down with density.
Yes, the light always migrates downwards. Whether or not it's a ray, I don't believe it's a ray. I believe that it's more just it's a different form of vision that we have. I don't believe.
Someone.
I don't believe that it's
into the chat.
I don't know what a different form of vision would be.
Well, let me finish. So I believe that what we observe with our eyes, we aren't looking at beams of light shining into our eyes. We are looking at a different form of vision. So saying that we can use a laser and stuff like that, a laser's good to demonstrate the principles inside the tank, but I don't think it has the same, it's not the same thing as looking at an image in the tank or something inside the tank, a physical thing that you can touch.
So you think, so what is this different?
So let me finish.
I thought you were done. I thought you were done.
Right, okay, so the physical thing that you can touch and place inside the tank, the way we visualize that, how we see it, however it represents itself to us, whatever comes to us, or how our eyes perceive what we're seeing, ends up bending things down. Now, with lasers, yes, you can make lasers bend down and stuff like that, but they're more something that you cannot touch. You cannot touch that. Those lights you can't touch, you can't fit. They're not tangible. But the things that are tangible have a different vision to what a laser has. So what I think that when we put a similar thing inside these fish tanks to perhaps recreate Soundly's pylons, we will see that same effect. I'm pretty sure of that.
What is this thing that you can't touch, that you think you can't touch?
Well, you can't touch a laser, Brenda. The light
yes,
from
you can.
Well, you can touch the physical laser.
Can.
How can you?
Yeah.
Can you?
You can shine it on your hand. It'll burn a hole in your hand.
So you can grab it and you can move it around. You can play with it.
You can.
It's
bend
not a physical thing that you can touch, Brenda.
Light is physical.
It's not a physical thing that you can touch, Brenda.
Yeah. Yes, it is. Yes, it is. Light is physical.
The table.
Shine it on your.
This table is a physical thing that I can touch. This keyboard is a physical thing I can pick up. The mouse is a physical thing I can click. But the laser light, I can't do anything with that.
Yes, you can. You can shine it on your skin and it'll burn. If it's strong enough, it'll burn a hole in your hand.
Can I tap it so it makes a noise?
Yes or no, yeah.
Can I tap it so it makes a noise, Brenda?
It will burn a hole in your hand. That's all you need for it to be physical.
Can I tap it?
No, that's an effect of it.
Can I
tap
tap
it?
it?
The light physical.
Yeah. Yes, that's the effect of it being physical.
So can I?
Energy is physical.
So can I tap it?
Yes, it is. Yes,
Brenda,
it is. Energy.
I don't want this to get
energy.
into a semantic argument, Brenda.
Brenda is right. It's a little bit right.
So I don't want us to get into a semantic argument. I just want to basically explain the two different ways that we see. Laser light, something you can touch. There's two different things. So
They're not. You're wrong.
I'm getting a bit of feedback from somebody. Is that from you, Crow?
Is it me?
Possibly.
Oh, okay. I'll mute.
How's that? Yeah, that's better.
Can I say
that
the
was
laser
it.
can make a physical effect, but no. So Brenda is right and Ranty is right too. So I did yes and no.
No, Ranty is wrong.
Yes,
I'm right.
They both have a point.
No,
right. Well,
you don't.
anyway, the
The
simple
effect is physical, but the light isn't.
Light is always physical. It's part of the physical world. It is
Yeah.
it is stand out in the sun. Stand out in the sun for 3 hours and find out what happens.
Yeah, that's
You'll
the
burn.
effect.
You'll burn.
The effect.
Because it's physical. If it wasn't physical, there could be no
It's
effect.
physical effect. Yes.
But magnets have an effect, and the magnetic flux lines aren't physical, but they
Yes, they
have
are.
an effect.
Yes, they are.
Okay, Brenda. Okay.
right.
Electromagnetism is real.
Yes.
It's
Of course,
real.
it's real. There's you're conflating what's real with what's physical and tangible. This is where our problem with you guys comes in from the very beginning. You've changed what words are supposed to mean, like level. You change the meanings, and you can't do
That's
that.
the most crazy thing.
We haven't done that at all. We haven't done that at all. We haven't done that at all. We have not done that. We have not done
Level
that.
is not curved. Light isn't something you can hold. It's real. It's not physical. There's a difference to those words. You know, this is why semantics is important. This is why definitions are important.
Level being curved was defined in the 19th century. What are you talking about?
What are you talking
Level
about?
is horizontal.
No, it's not.
Horizontal.
No, it isn't.
Yeah, it is.
It's level is a local thing. It means it means
level is having no
equidistant.
part higher than another. A curve always has one part higher than another. They cannot be the same thing.
Curves are level because they're equidistant from the center of the earth.
No.
Yes, they are.
That might be your.
Yes. It's from the 19th. It's from 19th century surveying textbooks.
And that's what I'm telling you. You've changed the definition of what words actually mean to fit them into this curve. A curve has one part of it. The curved line, there is a part of that is higher than another part. A horizontal line, a level plane has no part higher than another. So if you say a curved line is horizontal level, then you're saying a curved line doesn't have one part higher than another.
So this definition is from like the 19th century, which is like over 100 years ago. So
you're not addressing what I said, Brenda. You're just saying the same thing again.
Yeah,
just because they did it 100 years ago doesn't mean they've changed. They still changed it like for thousands of years.
No, they haven't changed it at all.
All meant the same thing, and then all of a sudden you guys come along with your ball.
No, it didn't.
Yeah, you did. Does a curved line have one part higher than another? Does a curved line have one part higher than another?
Compared to what? I mean,
itself.
What does that mean?
Like if you were going to tell a child what a curved line was, would you tell them that a curved line had no part higher than another?
So
we're talking about.
Hey, please don't let it. Don't interrupt. Just let it. Please let the silence just go.
Why silence? If she cannot, find the words.
Thanks for that.
I hate.
Yeah, just let the silence. Just let it be. Don't jump in. Let her have her.
Everyone jumps in, so why don't I? Because I have something.
And I'm asking you not to.
Why would I listen to you?
Because Brenda and I are having a perfectly good discussion. There's no need for you to jump in. Just let her answer in her own time, as long as she needs to take that. Well, she doesn't need your help. She's smart enough to answer these questions on her own. Thank you.
I'd like to hear Crow.
Brenda.
Yeah, go ahead, Crow.
Yeah, she doesn't want to answer.
I was saying that there is a point higher than another point comparing to that point, but what Brenda's saying.
And on a level line, there isn't.
On a level line, yeah.
There's no part higher than another.
Exactly, you're right.
And on a curved line, there is.
Comparing to a point.
No, don't compare it with anything. Compare it with itself. If you were going to tell a child what a curved line was, would you tell them that a curved line had no point higher than another on it?
Comparing to which point?
Don't
Okay, I get your point. But in general, when we're talking about curves, we're not talking about just any curve on a paper. We're talking about the curvature of the Earth, and that's measured from the center of the Earth. So there's no point higher than the other on a ball.
And that's where we're trying to tell you that you have taken what is a flat plane and then wrapped it around a ball and taken it to the center of the Earth so that your level is level that's curved. But we're trying to explain to you that's not how it works.
Nobody took a flat plane.
Right, we got a bit of an echo.
It was always flat for thousands of years, and then they wrapped that around a ball.
Could we sort the echo out,
every
please?
ancient civilization thought it was flat.
People have known the globe is round for 3,000 years. So you're wrong.
Yeah, that's not very long. We've been here for way longer than that. Like that is like a 1% of the time that we've existed. That's like a drop in the ocean, that amount of time. It's nothing. I mean, they have watches now built on the Antikythera mechanism. $350,000 for this watch with that has the whole Antikythera mechanism on it, and that's all based on geocentric. The little Earth things in the middle, everything goes around it. There's your predictive model.
I would like to see a verified statement that is from 3,000 years ago that someone's found, indicating that any civilization just came right out and put down somewhere. It is absolutely a sphere. If you could show that, that would be great.
That's how it was taught. That was how it was taught.
How do you know what was taught if it wasn't written down? Please show us how it was written down. You can't know it was taught unless it was written down somewhere. You're saying that they said those things, you weren't there to hear them. So where was it written so we can read it? Where's the paper or the stone or wherever it was put so we can see it for ourselves that that's what was taught?
There isn't anything.
I didn't think
so.
so.
Want us to believe them. They just...
There's no actual proof that that's what people
so now
thought
they're
or
telling
taught.
it to us. Yeah.
Oh, it's what people have been taught. Educated people.
Yeah, and just as soon as you show us a verified piece of paper or stone or something where it was written down,
anything,
and that's cool. And until you show that, it's conjecture, fantasy.
No, it's not conjecture.
Well, I said what I said.
Well, it's not proof, is it?
I bring something
haven't
up.
Given any.
I present something, Ranty. All right.
Yeah.
Sorry, what did you say?
Whoever that is.
Sorry, what was that?
It's Chris. I was going to see if I could jump in and present something.
Yeah, of course you can, yeah.
Actually, on this Discord, I don't really have to do is
so you can
screen.
Yeah, you can screen share. So if you go to the show channel, obviously, down at the bottom you'll see you've got video and screen right above your username at the bottom. So if you say screen, it says share your screen. Click that and then choose which one you want to share. It gives you an option.
Okay. All right, so I'm going to screen share this. So I've been doing some sun tracking tests, and what we hear all the time from the ballers is that how many degrees per hour does the sun rotate does the sun move in the sky, and every time they say 15 degrees, right? They beat that into our heads. 15 degrees, 15 degrees, 15 degrees. In fact, that's actually not correct. Not only is it not correct to us, it's not correct in the ball model. You have to take in your latitude into account, apparently, and you have to do some math. Depending on your latitude, you actually get less than 15 degrees oftentimes. 15 degrees would be literally if you're like on the quote-unquote equator of the ball Earth. You would get 15 degrees. But so I thought, well, that's interesting. First of all, it's not 15 degrees, so that's just false. a second, I thought, well, what would happen if I actually measured the sun myself? So I did that, and I'm actually doing it. I'm probably gonna have to take about 5 minutes, go out and take my next measurement. But I'm gonna screen share what I've done so far today. So I went and got a protractor, and I set it up. I set this thing up to where it's going to cast a shadow on the protractor. As you can see, there's 3 images, each 3 hours apart. On the left, it's obviously starting at 0 degrees. Can you see this, by the way? Make sure.
Yes, we can.
Yes.
Right. So on the left, I obviously set up the edge of the shadow to be right at the 0 degree mark. So that's hour 1, and I have a timestamps, 13:51, so 1:51 Central my time. Hour 2, 14:51, 2:51 Central. If you look, you notice it goes to 10, 11, 12. And it's actually, I would say it's not even, when I looked at it, it wasn't even on the 13 degree mark. I would say I will give it 12.9 degrees change. Problem is my latitude, if you do the math, I'm supposed to get 14.4 degrees of sun movement. So not only am I not getting 15 degrees, I didn't get the required 14.4 at my latitude. Now, if you go to picture 3,
it's close to 4. It looks like it's close to 14 in the middle picture.
Have you seen Nathan's?
It's
Nathan and
yeah, sorry. Can I just finish real quick, and then we can have to go out and do my next measurement. I just want to cover the last image. So another hour, so 15:51, 3:51 Central my time. Got 20, 25, 6, 7, less than 28 degrees. I'm supposed to, at this point, hour 2, I'm supposed to be at 28.8 degrees, which would be somewhere over here. So it didn't catch up. I'm still shy of 28 degrees.
Looks like it's close. Shadow. Looks like it's close though. The middle image is close to 14, which is what you said it should be.
No, it's below 13. It's below 13, Brenda.
And then doubling that would put it at 28,
your
which
model
is about where it should be.
Brenda, you need to redo your model, Brenda. I'm sorry.
You said according to your latitude, it should be about 14.
14.4, almost 14 and a half. It's not even at 13. I'll give you 13. Now we're at 1.4 degrees off. In the third image, you should be at 28.6, and you're less than 28 degrees.
Well, Nathan and Antonio and them did a sun tracking thing and found time and date was like half an hour to an hour off. In lots of.
I would imagine that.
Have you ever looked at the equation of time while you do your findings of the period of month we're in, and the period, obviously through the week, the day, the month, and look at the equation of time? Have you compared your results to that?
Talking to me?
Yeah.
Oh, this is like today. I'm literally doing this today. This is the first set of tests I've done.
I'm saying you can go. There's an equation of time chart you can go and use, and it's based on man's construct of 60 by 60 by 24. What the equation of time does is will show you exactly what you're demonstrating is the acceleration and deceleration of the sun movement. And it's established already. It's called the equation of time. All you're doing is substantiating the.
How does the sun accelerate and decelerate?
Based on its path, the height of its path and the movement of its path. So
I don't think it.
I think you would find they would say that's the Earth's rotation around the sun that's elliptical and going slower or faster. It's got nothing to do with the sun moving in your model.
No, exactly. It's basically showing us that it's the Earth is flat and it's the sun it's moving in an elliptical path around Earth. That's what the equation of time
the Earth is moving.
Oh, right. I get what you mean.
So
the Earth moves in an elliptical pattern.
Yes, the sun is moving.
Yeah, it shows to me, the equation of time shows me, based on man's construct of time, that the sun is speeding up and slowing down, like Chris is showing in the demonstration. That's all I just wanted to say.
Yes.
Yes, yeah, it is. The sun does speed up and slow down. It does. Like
no, well,
in
it's
either
the Earth.
model, we just say the sun, and you guys say it's the Earth. Yeah, like, yeah.
But Chris, the angular speed of the sun does not depend on the latitude. It depends on the declination of the sun.
It will actually calculate to the minute whether it's behind or in front, right? That's what the equation of time does. So it actually shows you the oscillation pattern, and it shows you when it gets close to man's construct of time and then moves away from man's construct of time. It shows the deviation.
strange because I concluded the equation of time before I knew that there is something even called the equation of time, and I plotted the solar analemma using these equations based on the heliocentric
So it
model.
shows you against. You have to realize the equation of time. The derivative of 60 by 60 is the observation of the sun movement. It's the quantification.
There's no such thing as 60 by 60. I don't know what you're talking about.
It's the
I've never heard
60
of that.
seconds, 60 minutes make an hour. What don't you know about 60? Are you serious?
Can you give us that
I'm
equation?
saying I made the equation of time on my own without knowing that it even exists. And I've never used anything
Wow.
that's called 60 by 60.
So, okay,
What?
so the thing is,
What
you've
are you
used,
saying?
That's amazing. He just made an
Amazing.
equation of time himself.
yeah, he
Yes.
used the construct of
And
time,
it's on my
Unbelievable.
and then
channel.
he matched the sun
Wow.
time to the construct of man's time, and thinks he come up with something. Buddy,
You are
the reason why
assuming
we
what I
have
did.
60, the reason why we have 60 by 60 by 20 is because we watch the sun. It's a quantification of it. What it shows you is man trying to quantify it to give you 24 hours a day. It shows you that it's sometimes earlier than 24 hours a day and sometimes later than 24 hours a day. That's reality. The 60 by 60 by 24 is a quantification of that reality. It's a construct. It's not actual reality.
Exactly.
So what? Anyone can multiply 60 by 60 by 24. So what? And where did
Yeah, but
does
he's
that
showing
take
that
you?
that's the sun
You
moves
realize
differently to that.
we have to add an extra full 24 hours to the calendar every 4 years because of this problem, right? We're not
Yes.
our calendar doesn't match reality. The Hebrews don't have that issue.
Time
The Hebrew
concept.
calendar and the Islam calendar doesn't have that issue. It's just North America that has that problem, and that's just something you should.
It's right.
Well, on round table 7, I've made a presentation about the solar analemma, and I showed the equation that I've used in order to conclude that amount of shifting to the left or to the right, depending on the date. So, yeah, that's what I want to say. And Dave Marsh made an observation from London, and Jenna Friedel from New York. They were measuring the angular speed of the sun using cameras during noon, and it was not 15 degrees per hour. It was like 13.7, and that's the minimum speed you would get during summer or winter. If you want to know the angular speed of the sun, you just multiply 15 by cosine the declination angle of the sun on that date.
Really? Do you think the sun can be in a different elevation too? And different altitude? Do you hear me?
Yeah, we just didn't. He didn't come through very clearly. Then it was a bit muffled.
I'm asking, just thinking about if the sun can be in a different altitude elevation also. Just thinking about it. If the sun can be in a different altitude. Somebody.
A different height, like does the sun go up and down as well as around? Is that what you're asking?
Yeah. If it's in the middle of the earth, that is the highest of the North Pole. It's like in the magnetic electric field. They can be in a different altitude in the field. So it's not all the time in the same height. The sun can move up and
Yeah,
down.
I would think that them tilting the Earth and their explanation for seasons and stuff on. If you think about that on a flat Earth, that might mean that the sun could be going up and down as well as around.
I heard they are talking about the sun can go in a pattern like an 8 in the field.
An 8, yeah. The thing Crow shows that on his little thumbnail.
Yes, it looks like an 8, but it's in the electromagnetic field. It's going up and down in a path of 8. It's something like that.
Yes, yeah, that's what it does.
The sun cannot go high and low.
Yes, it can.
Why not?
Because it's not physical.
Because in the
I can shine a
electromagnetic
laser light
field,
up and down on the wall.
You know the arc
it's
minutes.
light.
The arc minutes of the sun changes size, right? You know, in the sidereal information, when you're measuring diurnal motion of the stars, sun, and moon, it shows you the angular size of the sun changing daily to the observer. You realize that, right?
Yeah.
Yeah.
Yeah, I don't see in the real sun.
So
It's apparent sun. It's apparent light.
It shows you that there's an apparent size change, right? Your model suggests that the sun is 93 million miles away. And you're suggesting that the Earth is going through all these tilted motions. And through these tilted motions, you're changing the angular size of the sun, right?
But
Now,
it does.
Which angular
The
size?
sun
Vertical
doesn't
or
change.
horizontal?
So as it moves away from the observer, it changes its arc minute. So its angular arc minute degree changes, right? This is measured data
much?
that you can look.
No,
very,
not
very
right.
insignificant, very insignificant towards the data in sidereal, but it's noticeably mathematical. Or sorry, let me say it's noticeable in the math. You can see it change in the mathematics. Optically, you're not going to probably see that for the most part, unless you're using 50 mil with a heavy solar filter. You may see the sun size changes.
That's due to the Earth's orbit.
There is no orbit.
So as
No,
objects
there absolutely
moving
is.
away, yeah, there's
Not
no
through the
motion
day.
of the Earth, right?
Not through the
So
day.
you-
It changes through the year.
It changes through the year because of the Earth's orbit is elliptical.
It's
but
changing daily.
day to day,
Okay,
it
so
doesn't
as
change.
it
No,
moves-
it doesn't change.
It
It doesn't
changes
change.
daily according to the sidereal
It doesn't.
information.
If it changes
No, it
yearly,
doesn't.
then it is changing on a day-to-day basis.
That's correct. So as it's moving
You
through
can't,
the
you can't change yearly without it doing that on a day-to-day.
Unless it changes very suddenly and in a very big way.
Unless it just does it on one day.
I have a question.
It's a constant
Dan.
movement through its cycle. So what it's doing is it's going higher and lower in the sky through its season. So if one observer is in the north, he will see over the season the sky. The sun is lower in the winter and higher in the summer.
That's just apparent. That's because of the tilt of the Earth.
So what you see is you see the sun grow closer to you, and as it gets closer to you, it increases in arc minute size. This is a sidereal motion that you can measure. It's already there inside stellarium data. It shows you that it increases size. Your model suggests that the sun is 93 million miles away, massive, but yet it appears to be the same angular degree size as the moon, and yet through the same cycles, you still have that apparent size change.
The size change is due to the orbit. Is due to the elliptical
Does
orbit
that
of
happen
the
to
Earth.
the moon?
There's no motion of the Earth, my friend. It's diurnal motion. It's measurement of this.
No,
it's not
we
measuring
know
Earth
that the
rotation.
Earth is. We know that the Earth
No. When
orbits.
you measure, when you do diurnal motion or the sidereal information, you're measuring the movement. You're not measuring Earth rotation, bro. You're measuring the movement of the stars in the sun.
I'm not talking about Earth rotation. We're talking about Earth's orbit.
Yeah, we're not measuring anything with orbit. We're measuring the diurnal motion of the sun, moon, and
Well,
stars. We're coming up with
Well,
measurements.
the reason that the sun's angular size changes throughout the year
We know what you
is
say.
due to the
Listen
orbit.
to me, Brenda. We know your.
Stop interrupting. So
You're not letting me get it out. So the point is that the study of that information is not using Earth rotation. Okay, don't study the diurnal motion of the sun and moon and stars by studying the Earth rotation. They study the movement by the Earth is stationary. Then they study the movement of the stars. That's how they get the angular size change. The angular size change isn't based on its orbit. You understand? It's based on the rotation above, not Earth rotation. Because there's nothing in the math that says Earth rotation. Okay, it's diurnal motion. It's measuring the movement of the sun.
Diurnal notion is apparent. Is the apparent notion? Is the apparent motion?
It's the study of the movement of the. It's not the study of the Earth. It's the study of movement of the stars. Get that
right, and it's their apparent motion.
So when you go look at the math,
I think it can be two-dimensional.
There's no, especially when you study the sun and Lima, and you look at the 1300s when the Arabics, they weren't studying Earth rotation.
Diurnal motion is caused by Earth's rotation about its axis.
In the 1300s, fellas. Okay, there was no study.
It's caused by Earth's rotation.
Listen,
Brenda's getting triggered. She can't let him even finish.
There's no question in earlier 1300s of rotation of Earth. Okay, it was still quantified as a celestial sphere that was rotating. Earth was stationary and geocentric. There was no introduction of this.
I don't care about 1300 years. You know, the 1300s.
It's very important today. To know about it because you have to ask yourself
no, it's
why.
Not.
Yes, you do, because you have to ask yourself why in the early 1900s did Einstein have to come up with special theory of relativity?
Relativity has nothing to do with diurnal motion.
Of Earth rotation, there's no reason for the formula.
No, it has nothing.
They still don't have evidence.
Rotation of the Earth has nothing to do with relativity. The rotation of the Earth has.
Yeah. So I'm done with
the rotation of the Earth. The rotation of the Earth.
Wow.
No, I didn't. No, I didn't. The rotation of the Earth. The rotation. Whatever. What the rotation of the Earth has nothing to do
the apparent
with relativity
of the stars, Brenda. What causes it to be apparent that the stars are moving? Is it because you're in a relative? You're looking at it relatively.
No, it's caused by the rotation of the Earth.
That's what I'm saying. Why do they then say it's the Earth? Because they're saying it's relative.
Where is the proof for the rotation of the Earth?
Diurnal motion.
I can't believe you don't get that. Wow.
Diurnal motion is diurnal motion is caused by the rotation of the Earth.
Where is the proof for it? Where's the proof for the rotation?
Stars, not the rotation of the Earth, buddy. Get your
Yeah, why would you see stars moving and then say, "Oh no, that's the Earth moving"? That's silly.
Not because it's actually it is the Earth moving and not the stars. It's simply an apparent motion. It's simply an apparent motion.
The Earth, they studied
apparent why?
Because we're on the Earth and the Earth is turning, and so therefore it looks like.
So what's that called?
They did not.
That's called apparent motion. That's called apparent motion.
Now you're squirming now.
1900, they started studying rotation of Earth, Peckerhead. 1900s. There's nothing studied of rotation prior to then, dude. Einstein was the savior of it all, so they could push
Kepler
forward.
did it.
They're
Kepler,
Kabbalistic.
not Einstein.
They're Kabbalistic. There was no proof, dude. There's no experiment.
Relativity has nothing to do with diurnal motion.
Experiment. All it was the study of the movement of the stars. This is a fact.
Yeah.
There was no
diurnal motion has nothing to do with the rotation of the Earth.
If you keep on saying it won't change the fact, Brenda, just move on.
Show me any literature, any
stuff record.
Okay, I just want to say, Flat Earth Data, your mac's a bit low. I've put it up as much as I can, but there's nothing more I can do.
I don't know what to tell you, bro.
I'm hearing a weird term. I would like someone to explain it to me.
It's good enough, but it's not great. Go ahead, Crow. Sorry.
Diurnal speed. What was that? Diurnal rotation.
Diurnal.
What is that?
Diurnal. Diurnal.
No, it has nothing to do with urinals. It has to do with it. It means it has the root in day, so it means the daily motion, the daily apparent motion, the daily apparent motion of celestial objects due to the rotation of the Earth.
Oh, okay. Thank you.
And to prove that, you would have to stop the rotation of the Earth and make sure, using the scientific method, that that's what was causing that effect. But you can't, so you don't have any actual proof.
So says you.
Well, I think by common sense,
no, so it's science. You must control your variables, independent variables and shit. You can't just.
What if we cannot control the stars? We have to resort to other methods. If we cannot control the universe, then we have to find other ways.
Yes, but that's not. You're then just correlating. You're not actually proving.
One way that you can prove that it's the rotation of the Earth versus, say, the rotation of the objects in the sky is by the use of Foucault's pendulum, or Bob Nodell, 15 degrees an hour, fiber optic laser. No, it proved
So
it.
I just
Bob Nodell proved it. He proved it.
So
He proved that the Earth rotates.
The pendulum left the
hold on,
rotation
because
of
I
the
just
right. Give me a break.
I just did a measurement and I'm not getting 15 degrees per hour, Brenda.
Oh, that's brutal, that one. Mind you, what time's that? 16:55. Is that? Were you 4 minutes late on that?
Are you talking about the one I'm screen sharing now?
Yeah.
So this is very odd. So you know, again, to be fair, this is my first day, so I'm gonna put more stringent controls on this. So at 15:54, I reset it to 0 because I wanted to line everything back up. Then I go back out an hour later at 16:55 on the right, and it's showing almost 21 degrees movement. So I can't reconcile that. And I thought, oh God, maybe like the wind blew it over, or the dog knocked it over. But if you look at the setup hasn't changed. So it's sitting on top of this thing, and I placed some rocks. Like there's a brown rock here next to the point of the protractor. There's a brown rock, the same brown rock here. So that hasn't moved, not an inch, not a millimeter.
Did you say 21 degrees?
21 degrees, yeah, in 1 hour.
Wow.
So what's Chris? What's this time?
That's preliminary.
So the time I can see the timestamp. So let Brenda, I'll tell you. So it's 15.
I don't see it. I
can see it. So it's 15:54 on the middle one.
Here, and this one's right here.
And it's 16:55 on the next one. So
I turned this picture on its side. I took it from from a widescreen angle because I thought I thought, oh God, the thing got knocked off, or it moved. So it would have had to have moved several centimeter or millimeters or inches, half an inch or whatever over. But I'm looking at it and I don't see a change. The thing it's sitting on is like a little cup. There's a gray rock right here, and that same gray rock is still there, but it hasn't moved. So I'm kind of baffled by this, to be quite honest.
Well, I think there could be a more accurate way to measure the angular speed of the sun.
What, rather than using shadows?
So.
What, rather than
Rather
shadows?
than using shadows, which will be perfect.
With shadows, so Eratosthenes was okay, and you'll use that as proof, but.
And by the way, I was using a theodolite app, and someone told me to go get a protractor. One of the ballers told me that. So this is actually an improved process that I'm implementing here.
Okay.
A recommendation of a ball tard.
Let me give my proposal. If you don't like it, then do it. It's very simple. You're going to use a pen as an omen. Just put it vertical, and tie a thread from the tip of the pen and to the tip of its shadow, and then wait another hour and do the same thing. So you have 2 threads with a separation angle. Then you can picture this angle of the thread. And
why doesn't this work?
Yeah, exactly.
He's done better than that. He's put the protractor there already. So you're saying take away the protractor, put 2 things, and then measure it with a protractor after.
The protractor's broken. Wait a minute, the protractor's broken.
No.
Oh, it's got to be.
Yeah, it's definitely broken.
No, not the protractor. It's good.
So it's right then. So it's 20.
Angle, look, the pen in the next picture, the one on the right, is taller. So there's a component to the angle going up, but he's not measuring it.
What do you do? Hold on.
The shadow moved to the right and up.
It's pretty blatantly obvious what it's showing. I mean, everyone can see that it's moved 21 degrees. But listen, how about doing a live stream of this tomorrow at the same time when you've got this big jump? So if it's the same sort of time, you might be able to get that same if you do a live stream of that.
Yeah, I probably can't do a live stream, but I could try and record it.
Yeah, that might work. Yeah, you just record it and then just speed it up put a clock on the floor.
Because if this is real, let's say there wasn't, I don't know, I'm almost, when I first saw it, I was like, oh God, like I said, something happened, the dog knocked it over or something. But I brought up these 2 images and I'm comparing them. I'm like, I don't see any difference. There's nothing that's changed. So yeah, if I'm almost kind of hoping that something messed up, because this could be insane, right? The amount of angle change due to the shadow.
Get a bit of echo, by the way. So somebody's got the mic hold.
Yes.
Oh damn, it's me.
So yeah, I mean, if you could do it, if you could record this and have like a
this is preliminary. Look, yeah. Look, this is preliminary, right? I'm making that session, so I don't know if something happened or what, but I'm gonna do this again tomorrow for sure. Now, like I said, I'll shore up the setup and I'll do my best to record it. The only problem is I only have an iPhone, and so I don't know. Can you record on an iPhone for an hour without it like getting overheated or getting out of storage? That's my only concern, but I'll see what I can do. So.
Okay. It just might be. I just thought it might be worth doing. I mean, I know that you've got the images with the timestamps on, but you know what these globers are like. They won't believe it unless they actually.
And that's why, in fact, I use the Theodolite app that I have, and the only reason I use that instead of the normal camera is because it put the timestamp on there. Otherwise, I didn't know how else to do the timestamp. And putting, like a watch next to it, which I didn't want to do. So the timestamp is from my iPhone. It's synced with the clock on the iPhone, obviously. So that's why I use that Theodolite app, which is why you see the crosshair in the middle. There's no other reason for the crosshair and everything else. I just used it for the timestamp. So I reset it up. So I reset it to 0 because I was like, okay, something happened at 4:55-ish or whatever. Oh no, yeah, exactly, 4:55. A couple minutes after that, 4:57, and I'm gonna go back out again, and an hour later, and do it and take another measurement, see where it's at.
Can I ask what does this mean? If it's 21 degrees, what is this about?
Hello?
What is this about?
Chris?
Show.
I don't know what it would mean. The only thing I can definitively say is with almost certainty now, after having done this a couple of times, is that the sun does not move at 15 degrees per hour.
Really? Are you saying it's moving in 21?
Can you use the Theodolite to? Yeah.
I'm definitely not saying that. Like I said, this measurement is fishy, so I'm gonna double and triple check it. Do it again tomorrow at the same time.
Well, all you're doing is some science, and you're reporting what the information is. That's the information. Let other people decide about it.
That's right.
I just want you to be careful of one thing. Where is the shadow moving? Is it moving like around the center of the protractor, or moving into another direction?
Point of the protractor to the right.
Super low volume.
Hello, can you hear me now?
Oh, not you, the other person.
Okay, so if you take like 7 hours, is the shadow of the pen is not going to be the same length, right? And this means that you are not measuring the whole angle.
The only place you... Go ahead, Chris, sorry.
George Natchik in chat says the sun arc trace changes when you project it onto a horizontal plane. So what he's saying is we can't use sticks and shadows to measure anything because it's going to be contorted based on the.
I don't
That's
think
not how it works, Chris.
So how does it work, Carlos?
You don't just grab one thing and say, oh, because of this, and you can't do that. Same thing.
That's what George is saying, Carlos.
That's what George just said.
And you said he can't do that, so thank you. No, he can't do that.
George didn't say that you can't use the shadows for anything.
The measurement of the angles of the shadow is not the same as 15 degrees per hour. We're measuring two different things. One is triangulation, the other one is rotation.
So how do I do it, Carlos?
Not this way.
He doesn't know, but not this way.
Hey, good.
Hey, Ranty.
Hey, everyone, it's Aaron. I just tuned in, and I'm just got a quick question.
Okay, go ahead.
Sorry, could you not hear me talking?
Yes.
Okay. No, thank you, guys. I just have a quick question. Am I still roboting? Sorry, I just sneezed. That's
No,
the
you're
sun.
not.
Are you there?
No, you're not. You're
Yes,
not robotic.
yes, we're here.
You're fine. You're fine. Go ahead.
Oh, cool. I just had a quick look at that picture. I'm not sure who was doing the measurement with the shadow, but on my phone, there's 3 photos going from left to right. The middle photo shows it at 0 degrees, and the far right photo shows it at exactly 16 degrees.
Yeah, that's the left-hand side of the shadow. That's the left-hand side of the shadow that you're looking at.
You have to use the right-hand side.
You have to use the right-hand part of the shadow, because the right-hand part of the shadow is on the 0, and I've got an echo again.
Okay, cool. No worries.
Bro, you gotta mute me.
All right.
And the right-hand side of it is at just after 20. I would say close to 21, but just after 20.
So George is saying I can't do it this way, right? So all right,
You're
George,
not
so
allowed to use shadows. You're not allowed to use shadows. But they were allowed to use sticks in the ground with shadows.
Yeah, he's not saying that you're not allowed to use shadows. He's not saying that at all. He's not saying
all right, let me read what he says.
That's the implication of it.
Let me read what he says. He says, no, that is not correct. On a stick shadow projected onto a plane, the time on each hour traced out on the plane changes between hours. Later in the day, the hour spacing gets closer. So
yeah.
So how do we measure the degree per hour of the sun then, guys? Come on. This shouldn't be this complicated.
You know, Chris, the funny part is when you research equation of time, that's exactly what they did. Is they studied the shadow.
Just stole that.
They studied the shadow movement based on the quantification of 60 by 60 by 24. So George is out to lunch.
What is 60 by 60 by 24?
About that?
60 seconds, 60 minutes, 24 hours. Oh my goodness.
Yeah, none of these are measurements.
Is my voice low?
When you start dealing with angles, you don't prove shape or measurements.
No, your voice
on
isn't
a
low.
circle, on a ball, on anything.
No,
So all you're doing
angles,
is tracking an angular. You're not tracking a distance, which will give us a
angles can
measurement, which will
easily
give us a shape.
angles can easily describe shapes.
Well, we're talking measurements, not shapes, okay? So in order to have a shape, you need to measure the outside of it, okay? So you can't tell me you measured a square and I say how long are each side and you go 15 degrees, because that's not a measurement of distance, so you'll never get the boundaries of the object measuring angles, okay? And this is what the ball earth has to do.
I have no idea what you're talking about.
Why did he just get muted?
He's not muted. He's not muted. I don't see any mute on anybody.
It seems like that tends to happen
just
with
dropped.
him, maybe for some reason.
Yeah.
That's the thing, though. When
Nobody's
you're doing the
muted.
shadow with the
What are you
sticks,
talking
you're
about?
actually
Nobody's
using
muted.
length.
Nobody's muted, no.
Carlos is quiet.
Yeah,
what?
You can, the shadow.
Oh,
the
there you
shadow
are.
thing,
You're back now.
especially when it's like 14.4, 14.6, like, it's all different all over the. It's not.
Yeah, if I said to you, Chris, I've got a 15 degree angle here. What shape is it inside? Do you know?
Come on, man. How are you gonna know? It makes all the angles do. They all make one thing: a circle. Okay. Now, whether that circle is being viewed from a flat stationary plane, or whether that circle is you on the circle as it moves. You know what I mean? Either the sun makes a circle or you're making the circle, but all you're doing is tracking a circle. You have no idea what size that circle can be.
But,
you don't think it's weird? The only method we have to measure the Earth is this angle stuff.
No, that's not the only method we have.
Anything better?
We have lots of methods.
They stick with the angles because it's malleable. They stick with the shadows because it's you can deceive with them. That's why.
Exactly.
You can't. How do you deceive with shadows?
Because if you took a straight line, I'll tell you how you do it. You take one straight line, okay? If that straight line has no curve to it, you're going to have a 90-degree perpendicular between two ends. If you shine a light on those two ends, they're going to produce the same angle. If you change the straight line into a curve and you have one that's 90 degree and one at 45 degree, and then you shine a light, they're not going to match the same angles. That's how you do it.
What the fuck are you talking about?
George says you can measure it.
From Brenda.
I clearly just told you what it is.
I think you made a little bit too much sense.
No, I just talk like so. Are curse words not? Because some channels don't want curse words.
Why are we talking about curse words, bro?
talk about what I just
No, I didn't say
said.
it wasn't okay. I'm just pointing out that you just happened to be the first one to lose your temper.
I'm not. I didn't lose my temper. What are you talking about? I just
Sure sounded like it.
It's just talking. What are you talking about?
Yeah, what Flatter Data said made no sense to me either.
Take a straight line, two poles in them. They're going to produce 90-degree angles. When you shine a light, these two poles from separate distances will produce the same shadow. If you have one that's 90, one at 45 degree, which on a ball you must, if you have two poles, they're not going to be perpendicular to each other. Therefore, produce different angles along the same line, which isn't reality.
Oh, but then you can use that difference in the angular measurement to calculate the circumference of the Earth, and that's what
Not
Eratosthenes
along
did.
the same longitude line. Do you want to know why it doesn't work along the same longitude line, Brenda?
It doesn't matter.
Do you know
because
why
we've
it
used,
won't work
we
along
used
the same longitude line, Brenda?
It doesn't matter.
Do you
because
know
we used
why it
multiple-
doesn't work along the same longitude line, Brenda? Or no, you don't know why?
We used
Tell me the difference
multiple-
between two pieces that are 90-degree perpendicular versus one that's 90 and one at 45. Will they produce the same angulars along the same line or no? No, they won't.
So Sparkane used
Brenda,
over 20
I just
people.
gave everybody a simple example proving that one pole at 90 degree, one pole at 45 along the same line will not produce the same angle. Okay, it's really that simple, man.
Right. So
By now, according to George, if you use a shadow and cast it onto a plane surface like Eratosthenes did, then it's just not going to work.
Hey, Ranty, I was going to show you something really quick. Can I share my screen?
Of course, can you?
So I was messing around with Blender again, and I decided to take Pontchartrain into. So this is awesome. Let me just start over here to show you what I'm doing. Let me know when you're up and running here.
Yeah, that's fine. Yeah, we're showing.
Okay, hold on. Maybe I'm behind.
Yeah, I'm presenting. It's a 30-second delay on YouTube, so.
Okay, so let me just delete this and go new. So what I've done here is you can download a beautiful feature for Blender, and it allows you to get straight on 90-degree shots anywhere in the world you want. And basically, this is Pontchartrain. And so what I wanted to do is use this little feature to show you. If I grab this little data here, it's the elevation data. And
yeah,
this elevation data will show you. Now, what I'm going to do is I'm going to exaggerate if it lets me, if it's not glitchy. Sometimes it's glitchy. But if it will let me, I might have to reload another one up here. Let's just see if I can change.
It's weird how it's presenting it on a flat plane, isn't it?
Okay. Yeah. So here I'm just
not really weird at all, is it?
I'm just being really exaggerated here on the elevation information here. So I've just I don't know. You can see it there. I've really exaggerated it. Here's what's something really cool about Pontchartrain. So it's flat, but you see where the construction humps are?
Yeah.
Those are the construction humps.
Oh wow! Yeah.
I wonder if Soundly's just zoom in on one of those construction humps from a long distance away. And all this is exaggerated. Let me just bring down back this exaggerated stuff. So I'll lower the elevation here, and it's completely flat, nothing to it, right? But if I raise it up to extenuate, you can see the little.
So you're changing it.
He's exaggerating it.
Exaggerating the elevation data.
Yes, that's called lying.
But it's weird that the water isn't.
No, he's just trying to show how it's not.
So check it out.
Flat.
Really exaggerated elevation data. Look what happens to the bridge.
So it does grab the data. That's really weird.
Lying.
So they've presented it on a flat plane. The bridge is flat.
Lying about it being flat?
The bridge is flat except for the humps that they go over.
Yep.
And you
they
can
show you the humps.
that. Yeah, that's pretty cool.
This is called CGI.
Yeah, Brenda. It's called elevation data, which I'm exaggerating to show you there's no curvature over 15 miles. It's flat as fuck.
Yeah. So you've
go.
cranked up the
elevation
vertical
data.
scale.
Yeah, so if there was any curvature there, Brenda, it would be so exaggerated at the moment, but it's not. The only thing that's exaggerated are the different heights of things. There's no curve in there anywhere.
Elevation data. That's it.
Yeah, this is elevation.
You want to try another place, Randy?
Elevation.
Any other place you want to try?
Exactly, because elevation has nothing to do with curvature.
Right, because elevation is the mean distance above sea level. Right, so it wouldn't show curvature.
But it wouldn't present as flat, though, wouldn't it?
Oh, no, it would present as flat. It would present as flat.
Yeah, but you have to then wrap it around a ball. It doesn't wrap around a ball itself. You do it.
No, that's what elevation means. It means a certain level above sea level, and sea level is level with the with the surface of the earth.
The good question would be
level with the surface of the earth, not
if we have
from the center of the earth.
If we did the same exaggeration with Google Earth, is the Earth radius going to shrink in order to show curvature more apparent?
So you realize what this is, right? Like, I'll demonstrate it again, okay? Just so you know. Let's go from scratch.
It's gone over their heads. It's gone over there. Well, or they're just blatantly ignoring it.
What place in the world do we want to see? Oh, Blender crashed on me. Hold on here.
He's simply cranking up the y-axis.
Elevation data. Yep.
The elevation data. Yeah.
That's right. So I crashed it. I just have to reload it here. Randy, any other place you want any other place that you want to look at?
Currently, no. I mean, Lake Pontchartrain is pretty cool because Brandon, Toy, and myself are going to be doing some little tests on that. Well, not on that, but trying to recreate things inside the fish tank to emulate what's going on there. So, yeah, fire another one up.
Right. Well, we want to see the salt flats or anything like that.
The Bolivian salt flats, yeah, that'd be pretty cool.
Who knows how to spell that? Let me just see here. You know how to spell Bolivian?
Bolivian.
Salt flats. You know what's funny? I was doing this yesterday, looking at the largest lake, which is in Russia there, and really weird anomalies were happening with this data. It wouldn't give me to the location, and when I tried to do a section of the largest, the largest part of it, it wouldn't show me the data. So I just found it interesting that for a world full of
have you tried looking at like the North Pole
and espionage, I can sure look at
or something?
All the elevation data all around the world, man. Right? So there, I don't know if you can see the Bolivian salt flats now, but I have them up.
Yep, we can.
Yep.
Section of it. Let's just get the elevation data. Now, what's really cool about this feature is you can actually add maps over top of it, clearly showing that there's no curvature whatsoever. Let me just bring up some of these.
You do realize this is going to trigger the globe as no end.
Well, it's just why would an elevation map show curvature?
Because it should be curved, Brenda, in your little model.
Why?
It's the same elevation above the center of a circle.
Ranty, I'm going to show you this here.
Elevation just means equidistant from the center of the Earth.
Exactly. Which will give in your model
actually what it means.
A curve, and these aren't presented.
No,
as
it won't.
curved,
No, it won't. No, it won't.
They're not presented.
So what
as
I've done
curved.
here. What I've done here, Ranty, is I've actually made, I know this may look silly at first glance, but I made an observer's dome, if you will.
Oh, right.
So now this is exaggerated. Basically, all I've done is turned it into glass and basically made a sun move over top of it.
That's pretty cool.
Wow, that's cool.
To be honest, this is how I'm sort of envisaging it myself.
Yeah, so basically I just wanted to show that as things move away from you, they appear to move downward, but because the atmosphere above is going to have refractive properties, it's going to look like it's bending downward, right? So I just wanted to show this and this actual circle is the size of this dome is actually based on the 3-mile radius of the observers.
Circus was more accurate.
Well, because the best part about it, bro, is what's going to come following these videos I've just posted. Because this is actually, if the observer was standing on the shore, I don't know how well this translates, If this observer was standing on the shore, you can see the circumference here. This is actually the circumference of the observer's view. In other words, if we were looking above the observer, looking down, that observer in that position would see the apparent junction of the sky at that circumference size.
I think there's probably a different. I have a different idea of what this would look like, but the thing's similar. But you'd you'd start off at 3 miles at the bottom, but as you go higher, you would extend it, so it'd be like an inverted kind of.
You definitely above the horizon, I would say 10 degrees. You can see probably 16 miles, I think, before it actually starts.
Can you show the light source? Can you show the light source?
The light source of the sun. How come it looks like an oval?
No. In this simulation, can you show the light source and its movement?
In this simulation,
hang on one sec.
The light source is the sun.
So yeah, the light source is the sun, and that's what it's shining off. It's like shining off what you see, which would be the atmosphere. So the atmosphere, you know, when I'm talking about, you'll see the lensing from the sun with the real sun behind it. So to you, that's what it would look like. It's your personal little area or dome, so to speak, your atmospheric dome that's around you, and that's what it would be reflecting on.
I get that, but I just want to see the location of the light source in this blender.
Oh well, that's just it's just the sun. It's just a quick model. It's not.
It's all it is.
Straight across the top.
That's all it is going straight over the top, just like the cycle. So if you go into use Blender for default, I didn't change the sun. All I did is do the animation for the rotation of it. So it's a default setting in Blender. Anybody can use it and go see. It's the same way I presented the last thing. I didn't add any sun or any flavor. All I'm doing is moving it past as if it's daylight, nighttime. That's it. And what I did is I added a personal dome, which everybody has already probably seen this example. Or what I did is I wanted to turn it into glass.
Mm-hmm. So what is this supposed to? So what is this supposed to show us? What is this supposed to prove?
So
it doesn't prove anything.
It can't prove anything. It's just a model.
You're right. It doesn't prove anything, but it gives a concept. It shows a concept. It shows a concept.
Models prove nothing.
It shows a concept, Brenda.
It's an illustration to show you the effects.
No, models don't prove.
Yes,
it's an illustration.
Models prove nothing. You can make a model of anything and make it work.
So, Randy, what would you like me to show? I have other examples I can show you.
No,
they literally cannot.
Looks like the sun is going up and down under the model.
Listen, Crowe, all it's doing is moving past it.
Modeling is.
No,
all
it's doing a circle.
Listen, bud. All it's doing is moving past it.
Don't talk to me.
Calm down. Wow, don't be so triggered.
Just learn Blender, bro. Look,
before, Andy, that this would trigger the ballers?
There's no sun here.
Because you are doing it a circle
we're getting a bit hot under the collar.
Listen, bud. This here, I'm flickering off and on. This is the
Prove me
default.
Wrong. Prove me wrong. Show me the motion of the light source. Thank you. You're making it a circle above and under.
It's the default. Here's the motions. Here's the rotation. So all I've done.
He's not going to show you.
So it's rotating.
I'm showing you here.
Isn't that what he's doing right now?
Showing you right there. It's on
There's
the screen.
information.
Look at it.
There's
right
the location.
There's no sun there. There's no sun
there.
There's
the location.
No, the information.
There's
Can't
the
you
y-axis.
read? Location, rotation.
We want to see.
There's the rotation.
We want to see the sun.
Because they can't figure out from its.
Now I can turn this off. I can turn this off and create a new sun for you. Would you like me to do that so we can position the sun in a place to show you the same example? Okay, let's create a new sun for you. Where's the sun at? Light. There's the sun. See that little dot? Or is it right there? Let's just see if we can move it. It might take forever to move it here. The right one. Sun.
This is garbage.
Yeah. So this is a default sun. So it's not going to be at this position here. It's going to be above, and you can see it's just a default position. I'll just brighten it. It just brightens over the model. See that? So if I just take the coordinates of it, and if I do the rotation, it's going to either rotate this way or rotate this way. So it's just, but that's all it is I'm just changing the rotation of the sun.
So it's not a straight line movement like on the flat Earth.
In the particular model that I demonstrated, it's just moving above the observer. It's moving towards the observer and moving.
Rotating.
Listen to me. It's moving above the
No, it's
towards the observer. It's moving towards the observer.
It's rotating.
Right, hold on. I want to intersect here. Just hold on, both of you guys. Right, listen. He's just started with his Brenda. He's just started with his model, right? So he's just putting things together and he's just putting the concept out. I'm sure it will become more refined over the next few months. This is just an illustration to show his early workings, and there's no need to jump down his throat about every single thing that he's doing, because I'm sure he will address it in time. This is just what he's showing you, what he's been doing recently.
Yeah,
okay?
we're just showing him where it deviates from the flat Earth model.
That's fine. You can show that, but there's no need to just be so ridiculously aggressive about it. You know, the guys just started doing. You both were,
and going on, saying the same thing over and over and over.
Yeah, I'd have to find out why this. Okay, there we go. So what did I do to it? Put it there instead. So just 0, 0. Let's bring it down. So I just have to figure out the direction it's going at. Let's look at the last one.
Looks pretty cool thing to be modeling, though. I mean, I wish I had software like this.
It's free.
Is it? Can you link me up with that?
Even that satellite information is all free, bro. All that stuff that I took is free.
It's called Blender. It's free. It's free.
Really?
Yeah, it's all free, bro. And there's tons of tutorials online show you how to do this stuff. All of it.
So, is there a place that you can download it without viruses, though?
I both download it. Yes, you can. Just go to blender.org, dude. It's free right there.
Yeah,
blender.org.
Yeah, blender.org. Nowhere else, just blender.org. It'll be fine.
Trying to match the same.
There's lots of free software on the internet.
The limit of my software currently is with Paint, I think.
I think I had to move this crazy. I don't know. Let's just see.
Take your time. I know this thing is complicated.
It's no, what it is. What it is. I'm trying to emulate what I did in the last setup for the sun, but I didn't do anything. All I used was the default sun. So I'm trying to match the default sun, which I already have a default sun. So what I could do is open up another project and show you the default sun, and then do it from there. So let's just do that.
When you say the default sun, it gives the impression that default according to the mainstream science, which means the sun is going around.
Bro,
okay,
he just
see this?
To model what's illuminated. Remember, he doesn't
see this
need to
here?
model where the sun is.
See this here? This is the default. This is the default sun. So all I'm doing is going into my web data here, and I'm asking to give me this. And then what I do is I type in a location, which in this case is, let's do Hawaii because that's what we were doing. And let's bring in the view a little bit higher up.
What's the purpose of the dome thing? What is that supposed to show?
Okay, so there's Hawaii there again. You just go a little closer to it. Section it off. Should just do it. I don't know why. There we go.
Who's breathing into their mic? Right.
Nope, that might have been me.
Elevation data.
That dome's supposed to be the Bob Nadell's dome of observation.
There's elevation data there. Let's just exaggerate some of it. Too much. And then all I did was for the sun was I started here. I took the keyframe. I think it was rotation. Let me see where you're at here.
So what's the end goal in all this?
Showing you elevation data, showing you flat plains, showing you that over a section of 3 miles, there is no dip, drop, curvature, no 8-inch per mile square. Showing you that the observers, I have many Blender things I'm going to release.
Why would you expect there to be curvature in elevation data?
So what okay, listen, Brenda, what I'm trying to convey to you is for a 6-foot observer, there's an apparent junction of the sky and ground. All this stuff is showing you over a section of well over 3 miles, well over 8 miles, that there is no dip drop. All you have is a measurement of a horizontal surface with elevation data.
Because it shows,
concluding,
why would you expect elevation to show curvature?
Concluding that the observer's perspective, the apparent junction of the sky and ground, is based on an optical thing and not a physical curve thing.
Why would you expect
the reason why I'm
using
using this?
Curvature?
The reason why because it's against the horizontal means Okay, to
No,
get
but,
elevation, you need a
elevation is
horizontal
just-
means.
elevation is just
To get
equidistant from the
horizontal,
center of the earth.
to get vertical, you need a horizontal. Bottom line. Okay, this is what you have to realize is being presented to you. Presenting is horizontal information with vertical data. This is what's being presented to you. This is how elevation works. Elevation doesn't work off of curvature. Elevation works off of a horizontal measurement. Yes, that's how it works.
Elevation is equidistant from the center of the earth or the center of the
Good luck with that, Brenda.
GIS.
The way I measure it is off a horizontal surface, my friend, not with your
it's projected.
So
So
what you've just done is you've just used your fake wizardry. The bottom line is it's measured from a horizontal means. Bottom line from the story.
but
That's how
elevation
is
isn't going to show
quantified.
you curvature.
Bottom line.
Elevation
So
is never going
when
to
I
show
show
you curvature.
exactly, Brenda. So what I do is I show you this example of an observer with the elevation and horizontal data, because that's what I'm being presented is horizontal and elevation data. I'm showing that a 6-foot observer. I'm showing you that a 6-foot observer and that location between the elevation and the horizontal data has an apparent junction of the sky and ground.
Right.
And that's due to optics, Brenda.
Right. So
there
sea
is
level.
There is no curvature. The elevation and horizontal data substantiates a flat plane, and then with the optic understanding of the apparent junction of the sky and ground conclude.
So here you
that
have.
You just said there's no curvature.
Brenda, you said no.
So here you have the island of Hawaii, and at sea level, right there on the coastline, the elevation is 0. And if we move over to California, at the shore, the sea level is 0. There's going to be no curvature.
Exactly.
What? In your model, there needs to be a curve there.
No. You can plot 100 points on the ocean, all at sea level 0, and they're going to plot a flat line.
Hang on, why are we helping Brenda? Why are we trying to tell her what her model is? This is great. Yes, you're right, Brenda. There is no curve.
Brenda made a huge mistake when he said he was measuring to the center of the Earth. Altitude is not measured from the center of the Earth to the sky. It's measured from the ground. Yeah,
we're talking about sea level.
Okay, sea level is not determined for. You don't go to the center of the Earth and then dig up to determine where sea level is. So the center of the Earth has absolutely zero. It has zero to do with where the measurements are made.
So that's not true. So sea level, on the coast, sea level on the coast of Hawaii, the elevation is 0.
Okay, but how do you know the distance from the Hawaii's coastline to the center of the Earth? How did you measure that distance?
We know the circumference of the Earth. We can.
I don't want to tell you. Don't tell me what you know. Don't tell me what you know.
What do you mean? Don't tell you what you know. We know. That's what we know.
This is what I want to know. Here's the thing. You're saying you're measuring these elevations, right? Like now, Flat Earth Data saying he has his elevation data points from the ground, right, to where the elevation is, and he's tracked them and measured them, and there's no curve. Now you're saying, well, that's because you're doing it wrong. It's not from the ground. It's from the center of the Earth. So can you show us how you measured to the center of the Earth? Or you're just going to say, oh, we did some math?
Technically, it's not quite the center of the Earth. It's from the GIS.
The
GIS
here. A little bit off. It's left field, not center field.
No, technically, it's a geoid. It's the geoid of the Earth. But close
okay, well,
enough.
show us that then, Brenda.
So that's calculated from data.
So you didn't measure it, you calculated it.
That's what a measurement is a calculation.
No, a measurement is a measurement. A calculation is a calculation. That's why they're called different things.
No.
Otherwise, a calculation would be called a no, they're not.
Yeah,
a calculation is a measurement.
Yeah, it is. A calculation and a measurement are the same thing.
No, it's a calculation.
Brenda, can you calculate the weight? Can you calculate the weight of a dragon that's made out of gold, that's 5 feet tall and 16 feet wide? If I gave you all the other dimensions, of course you can calculate the weight of the, but it doesn't make him real. So now when you calculate a distance,
say it was.
Okay, but when you calculate a distance, that doesn't make the distance real. A measurement makes the distance real.
If the measurements are based on real data,
if the measurement is a measurement, it's real. If it's a calculation,
based on reality, but yours aren't, because we're showing you reality on the screen now.
Yeah,
no, they are based on reality.
No, that's reality on the screen.
That's not reality.
Those are actual measurements.
Oh, that is the better description. You're not even showing us anything at all. He's showing you how elevation data is shown on a flat plane, you know, depending on how high things are there further up. You are just saying we calculate it, but you're not.
Let's try something. Let's try something, Paige. Let's try something, Paige. What is the elevation of the beach in Hawaii?
A sea level beach. Sea level.
Yeah. What is that elevation?
Well, you got to define what elevation is first. Is elevation from the center of the earth to an imaginary point in the sky, or is it from the ground I can touch to a physical measurement in the air that I can get to?
I asked Paige.
Yeah, okay, but yeah, this is a community thing. So before we get into some quagmire of elevation, why don't you clearly define what elevation is? Are we measuring from the ground to the spot in the sky, or are we measuring from the center of the earth to the sky?
It's defined as sea level. So
I don't
0.
care how it's defined.
Yeah,
Where does the measurement go from? Where's
I
the
need to
starting
know,
point? The
am I
ground?
measuring from the middle?
Elevation and altitude are two different things.
Okay, now okay, but all I care about is the measurement from point A to point B that fits Flat Earth Data's map and his thing. So
I mean, if you can show me that they've measured from the middle of the earth to the sea level and then to the top of a mountain, great. Show me if they've done that.
Yeah, they've done that.
They've measured. They've actually physically measured it.
No,
because they physically measured from the ground. Yeah, but I'm saying, saying I can physically go and measure from the ground to the top of a mountain.
Paige, if you hand me a basketball, I can measure the radius of that basketball without popping it.
So? No, you would have to physically measure this. You would have to physically measure the circumference first.
Yes, and we've done that.
Okay.
Earth.
No, you have not.
Yes, we have.
I'm telling you.
Yes, we have.
When did you? No. Okay.
It's been
okay.
done many times.
It's been measured or calculated.
These are
Calculated or
surveys.
measured?
These are surveys. They're measured.
Okay, here. Let me. This is.
And the surveyors I know say they measure everything on a flat plane. They take measurements, then 50 meters or whatever. Then they put a little peg. Then they go another 50 meters. Check back on the last two, then go ahead, another one, put another peg. So they're all just little square, flat areas, and then you just put them all together.
That's land surveying, not geodetic surveying.
Okay, here,
exactly,
now watch.
And the land surveyors are surveying the actual land.
And
that's what we're talking about. Reality.
No, geodetic surveyors
measure. Can I show something as well regarding this?
Geodetic servers. They measure imaginary drop through the visual.
No, it's
not. They do math. They don't do actual measurements.
Math corresponds to reality. So yes.
Now, math is I heard this great thing. Math is a man-invented math. People like to think that there's a new math. Hang on. There's a new math discovery out there waiting to be discovered, but it's not.
Yes,
it's invented in the man's own head. So, okay, so go lift the rock until you find a new math formula.
Brenda, can you at least let somebody finish a sentence? Like, I can hardly hear what he's saying because every 2 seconds you jump in.
That's really
can't handle the wrong thing.
That's really rich coming from you, Paige. You interrupt everybody all the time. You completely disrespect everybody.
Just like
sure, Brenda.
You disrespect everybody, Paige.
Right.
Oh, I think she's brilliant.
You're one of the rudest. You're one of the rudest people here. You're extremely
I've never
rude and
sat screaming
disrespectful.
"fuck you, fuck off" for 45 minutes at anybody. I've never done that. I've never done that.
Hey, Brenda, can you do me a favor? I have an observation for you to do, and it's just requiring you to do a horizontal and elevation data. It's a real easy observation to do. It's I don't know if you can see Blender there. I did it's over a distance of 110 miles.
We don't see Blender. We see your web page.
Yeah, good. Well, I'm showing you this example here. So what I've done is I've taken the dimensions of 110 miles. I've scaled it down to 1/100,000 scale, just like a miniature model would. Just like we're doing in these models you actually see in Blender, but I decided to do one with just paper and, math calculation, right? So the above picture shows me where I've calculated in centimeters the height of all the objects and reduced it to 1/100,000 scale. If you look at this here, this is something that's duplicable, repeatable, and observable. And what's really awesome about it is when you do it, you realize that you don't actually have to add in any curvature. And of course, over 110 miles, there's about 8,000 8,000 of a foot drop based on the geometric drop of your ball. And the best part is it's not over water, right? So there's no not much refraction, right? So if you take the mathematics of your ball and scale it to 1/100,000 scale, between the disc, you'd get what, a 270 foot radius. If we scaled the 3,959 mile ball down to 1/100,000 scale, you get about a 260 foot radius. And this particular section is only 6 feet. So from position A to position B along that 6 feet, you're going to have about a 2.5. You're going to have about a 2 point position A. So sorry, let me rephrase that.
I don't see any letters. I don't see any letters.
Yeah. Okay. So from the observer's view to the end of the observer's view, which is in this particular case is Mount Jefferson, would be observer B. Let's say point B would be the end. Point A is the beginning. Point B would be the end, right? And at the end of the observation is Mount Jefferson. Well, you can see in this observation here, it's poorly displayed because of the small imaging here. But if you go to that site and try the images out and try it yourself and do a panoramic, because the key word here is the panoramic.
The bottom picture is a panoramic.
Yeah, and so is the top one. The top one's a panoramic too. I emulated reality. So what I did is I took the height of the mountains and the distance, just the horizontal information and the elevation information, and I reduced to 1/100,000 scale, not adding any dip, drop, curvature, nothing. And what I've done is I've used this model and I've baited, I don't know, hundreds of anti-humanitarian people looking for truth. In this particular example, I've gotten Christians, pastors, teachers, scientists, all this stuff with the math. Now, what I ask you here is along the 6 foot radius, how much drop should be based on the geometrical part of your model? Do you know?
If you're showing elevation, then you wouldn't expect any curvature since you have an elevation.
What I'm doing though is I'm showing you 2 points in reality. I'm scaling it down and it's matching observable reality. I'm not accounting for any curve. Over that 110 miles, there should be over 8,000 feet drop. There isn't. I'm not calculating for it. I'm not even negotiating it. And the best part about it is, Brenda, is when I go into Blender and I capsulate over top topography-wise of the same area, guess what it matches again? So not only from the vertical bird's eye view does it match my observation, but it's clearly repeatable, demonstratable, and it's showing you that there's no physical geometrical radius of 3,959 miles. You're welcome.
Yeah, I don't see how any of this shows that since you have an elevation map and you wouldn't expect to see curvature in an elevation map.
So, Brenda, if you take reality and you're going to scale reality down, you're going to either do it in two facets. You're going to use plain Euclidean or you're going to use non-Euclidean. And in your case, your model has non-Euclidean geometry, okay? It's ball mathematics. That means you're going to have to account for some dip, drop, something of a geometrical nature. In this particular example, all I do is Euclidean.
Just talking words. You're just talking words.
Yeah. All I've done is done Euclidean,
I don't think you even know what these words. I don't think you even know what these words mean.
Or horizontal and vertical, proving no dip, no drop. Now I ask you, this is here for anybody. To me, this proves there's no 3,959 mile radius. It's demonstratable.
How does it prove that? Could you explain it to me how it proves that?
Brenda, a distance between 110 miles between observation A and observation B, between that tangent point, how much geometrical drop is on your ball?
That doesn't matter if you're plotting elevation.
Yeah, it's elevation. It's not curve.
So elevation has to do with your 3,959 mile radius?
Elevation is.
Tell me how elevation has to do with your radius. It doesn't.
Well,
elevation is just
something.
Yes,
it does.
How does it?
Elevation is the distance above some reference point, typically sea level. So elevation.
So my elevation will change the radius size of Earth. Is that what you're telling me?
So no.
Exactly.
Elevation.
So why does elevation?
Typically,
why does elevation?
Excuse me. Elevation is the distance above a given reference point, typically above sea level. So sea level is usually 0, right?
So we agree, elevation doesn't change the radius. So I'm asking you, along the tangent line, what is the geometrical drop based on your radius? Because that's all I need.
There would be no geometrical drop. There would be no geometrical drop because the elevation.
How do we measure the curvature then?
Differently
along that tangent line. How are we going to measure
using elevation data? Because elevation data doesn't show curvature. So
I'm just doing a model with two.
Yeah,
elevation. There is no curvature.
I'm using
the elevation of the beach the elevation of the beach on the Hawaii Islands is 0, and the elevation of the beach on the shores of California is 0, even though there's a huge amount of curvature between them. The elevation map, the elevation map is going to show 0 difference between the beach in
So
Hawaii
Brenda,
and
you
the
agreed
beach
the
in
elevation has nothing
California.
to do with the radius. Elevation has nothing to do with the radius. You just agreed that the elevation has to do with
It's
measurement
the
from sea
distance
level.
above
Great,
a
awesome.
reference
Measurement
point,
from
and
sea
the
level. That has
reference
nothing
point
to do
is
with the
sea
radius.
level.
So listen, what is your radius? It's 3,959 miles, correct?
3959 typically.
Wonderful.
Yes,
Over
3959.
110 miles along a tangent line. If we were to put a straight tangent line 110 miles away from the beginning and the end of that tangent line, what would be the geometric drop of your ball earth over 110 miles?
Yeah, I don't know. So
Okay,
if
so it's
I have
8,000. It's almost 8,100 feet. Okay, basically that's the drop. Now listen, if I was to scale your earth down because I was thinking it was a ball, I would negate that curvature formula, or would I use that formula, or would I just forget about that formula? The drop. When I scale things down, am I going to add the curve drop in or not?
If you're
drop is,
and it doesn't matter.
I love these answers.
Drop?
They don't matter. You don't know what you big words. You guys are just so destroyed. It's awesome. Love it.
No. You just don't understand what elevation
Uh-huh.
means. It means your
He's
distance
he's
above a
insisting on
reference.
shifting the conversation back to elevation rather than addressing the point you're currently making.
Because he doesn't understand the point.
He just agreed elevation has nothing to do with radius.
Flat Earth data.
So
Flat Earth data.
Listen, if you're going to compress your radius of your ball, you're going to use a tangent line to adjust the curvature to make sure that you're scaling it to the right amount. So if we were to scale the 3,900, if we were to scale down, listen, if we were going to scale down the Earth at 3,959 miles to 1/100,000th scale, what would be the circumference, radius, and what would be the drop over 6 feet? These are very easy, reasonable questions to ask because it's based on the presupposition of your model.
You don't understand it. So let me
That's
speak
not an
for
answer,
a minute.
bro.
You've had a lot of time. I would like a little bit of time. So if I have a boat in the water off the shore of California, and I have another boat in the water off the shore of Japan, right? There's a huge amount of curvature between them, but they're at the same elevation. They would be at 0 elevation. And if I have an elevation map, that map will show both of those boats at 0.
So, Brenda, what you're doing is you're ignoring a blatant evidence of data that's horizontal and vertical. Yes, you are. And you're like, well, of course there's not going to be curvature in the Earth stuff. No,
because you have,
because there is none.
You're making
Number
this
one,
based
the data
on
shows you.
elevation.
The data shows you that it's a horizontal and it's an elevated plane. That's all it is.
If you're using elevation
between 2 points of equal elevation is horizontal, my friend. This is classified, diagnosed, dissected, and applied in every building construction possible.
So
2 equal points
that's
of
fine.
elevation are horizontal. This is an axiom of Euclidean principle. The point is, sir, this is how you measure your dip, your drop. If we were going to reduce your ball to 1/100,000th scale, please tell me how much drop would there be over 6 feet. And if you can do this, if you can break it down, and you look at observer reality.
California is at 0 elevation, and the boat by Japan is at 0 elevation, and the boat in the Indian Ocean is at 0 elevation, and the boat in the Atlantic Ocean is at 0 elevation. The boat in the Arctic Sea is at 0 elevation.
So why do you put them over a curve?
Moron! You are a
they're all at 0 elevation.
Did you hear what he just said, eh? Everybody listening, all he said was boats on an ocean level. Boats on an ocean level.
At 0 elevation,
boats on an ocean level.
Of course.
Oh, somebody's triggered. Somebody's been very rude and very nasty.
Zero elevation. What would graphing zero elevation look like? What would it become if you graph that continuously?
Zero.
Elevation
what would you
map.
get? What?
You
What would it look like?
Map.
Yeah, and what would that look like? What would that map look like?
That would look like a
right the hand. Wouldn't that
look like a what? What would it look like, Brenda?
Plane with elevation data on it.
It would look like a flat plane that said 0 across the board.
Yes, and they take that and wrap it around a ball.
Yes.
Whereas we can show that that's what we see in reality. We can get a picture and show that elevation data put on a flat base represents reality. They then take that and wrap it around a ball and go, no, this is reality. Well, hang on, you don't have it that matches that. We do. You don't.
Yeah. So where does this ball come from in this elevation? So this is the point Flat Earth Data was trying to make, that the elevation data is a flat plane. So where do you get a ball from it?
Yeah, if
The Indian Ocean is at 0 sea level. Hawaii's at 0 sea level.
Yes.
Yes, it is.
There you go. How did I know that's what?
There we go.
The beaches at Normandy are at sea level, at 0 elevation.
Yeah, so why do you then wrap them around a ball? Why would you do that?
Because that's the true shape of the Earth.
No, we've got photos showing that elevation data on a flat plane. He just showed it.
No, you don't. No, you don't.
Oh my God.
Oh my God.
Those aren't photographs. Those aren't photographs. That's Google
He just
Earth.
showed a photo before with a scaled model.
That's Google Earth.
Right now? No. The photo, the panoramic picture of reality, he did a scaled model of.
That wasn't reality. That was a panorama with stretching in it. You could see the clouds stretching in that image.
And what does cloud stretching have to do with curvature?
It means that the photograph was distorted.
Oh, Brenda.
That's
really?
You don't understand how panoramic works, then, right?
That's what a panoramic
These are data points.
What's that got to do with the floor? You should still be able to see curve.
It's a rectilinear.
You know what's funny I did with that photograph, is I reached out. If you go to USMGS website, I reached out to the guy who took the photograph. Not that one, but he took another one. If you go to Ranty, can you do? I don't know if you want to indulge me, but if you go to USGS, I think USGS website there, they'll show you this shot. Go look at it. It's fucking hilarious. They purposely put it together as a panoramic, but in a ball format. It's priceless. It even shows you all the stitching and everything.
Really?
Making it as a ball from the height of Mount St. Helens. I reached out to him as I sent him an email. I was like, "Hey, dude, that's a freaking amazing photograph. It's like you were like 90,000 feet in the air. How did you get such curvature?" It was fucking. I haven't gotten a reply back from him yet, but it'd be interesting to see. I'm trying to bait them to come in to get something, but I don't know, man. Maybe they're too clever. Maybe they just know it, and when they're asked a question, they're like,
you're much too clever. You're much too clever for them. I'm sure.
Yeah.
Of that.
So, Brenda, way more clever than you.
The ad homs coming out and the nastiness and the swear words. It's the only person here being nasty to anyone else.
I'm going to add home right now. If you think Brenda's the clever ones that come in here and talk to us, then you're sadly
they're not
mistaken.
concerned.
Yeah, you're not going to get a good one.
No, they're the only ones left right there. That's the only ones crazy enough to still believe this shit. NASA showed us a ball. Therefore, everything you're showing us on a flat plane that matches reality can't possibly be true because NASA told me it was a ball.
I'm going to try to find you that USGS thing, and maybe we all can send him an email and ask him how high was when he took the picture.
They're constantly asking us to model the flat Earth, model reality. You just showed that. You showed a scale model on a flat plane.
Yes, I did, Brenda. And not only that, I showed you how the radius of 3,959 miles doesn't.
I mean, if you want to ignore that, Brenda, that's your choice. You're your own person. That's fine. But everyone here and everyone in the audience can see that was a scale model of the picture. That's just all there is to it.
Well, hang on. The referee's checking the replay. Nope. Yep, Brenda, you're wrong. The ruling on the field stands. Brenda, you're completely incorrect.
Well, that's it, Brenda. Earth is flat.
Well, at least when Brenda comes in, at least we get her to be honest at times, even if she doesn't realise what she's saying.
I'm always
even if she doesn't know she's being honest.
Said it maps out flat.
I've
so.
never lied. I've never lied.
Yeah, so the data shows it's flat. Yeah, we all agree on something.
Yep, we agree on that. Yep, you weren't lying. Everything is at 0 elevation, no curvature.
Well, if you want to think that Google Earth is a flat Earth model, have at it.
Yeah,
Can I ask you, listen, Brenda, how are the images gathered by Google, just out of curiosity? How were they gathered? Because it's actually lots of data, but how is it initially gathered? Can you tell me, like?
I don't know, but I would assume it's from satellite images.
So if so if they're from satellite images, how far away are these satellite images, Brenda?
I have no idea.
Okay, so 8-bit sensor with a 50 mil lens, 21 mil lens, 10 mil lens, 18.
I have no idea. I don't know.
Made the satellites, first of all, figure out how far a lens can see based on the bit rate, based on the focal length size, and based on the field view. So a field of view, when you're taking land photography, field of view, you can only bet a certain height based on the sensor, or else you don't get fucking detailed data.
They're not taken from the Earth. They're not taken from the Earth.
100% taken from elevated, maybe 60, 70,000 feet tops.
No, they're taken from satellites.
Yeah, sure, 60, 70,000 feet tops. The point is that they're
know.
elevated over
no
a position of
how
Earth.
high they are.
They're elevated over a position of Earth where they can get the proper detail. Okay,
sure. And then they stitch them. And then they stitch them together.
Too far, you got diffraction. Too far, you got diffraction. Right? Infrared has a little bit longer of a wavelength. You can go a little farther out. But even using infrared and the 16 different types of sensors they use, they have to compile the data together. And they use it for land surveying, like minerals, jewels, content. That's used all this stuff, sound and infrared. Boom, boom, there. But this is only limited to certain height distance. Okay, and I urge you to present any information scientifically that shows the sensor ability, the size of the output magnitude, and show me that it's 20,000 miles up with a sensor to get that kind of topography. It's impossible. There's no technology on the world that can do 20 miles up to shoot a field of view with that much data. Infrared's only good for a certain distance.
Could you just stop
and optics are only good for a certain distance. This is a fucking fact.
Could you stop rumpusing?
The fact is I just presented to you topography shot with this particular equipment that is unbiased. Okay, because it's pointed downward and it's filling a field of view, a horizontal field of view, because it needs to measure elevation data.
Could you stop? Could you just take a breath?
Listen,
could you just take a breath?
You have to have a horizontal position to measure a vertical distance.
Just take a breath. Just take a breath.
Don't tell me what to do, but at the end of the day, you don't even know how satellites shoot the images. You don't know the software. You don't know the tech behind it. You assume
I don't have to know. Why should I have to know?
Because Brenda, I just offered you a practical demonstration.
You don't have to know, but if you want to know the truth, then you should
I've offered you a practical demonstration that you can either do two choices. You could either use Euclidean geometry or non-Euclidean to do the scale model. You can do it. You can do it.
So
you can do it, bud. You can do it. I know you can. Number two, you can also study how cameras are taking topography of Earth and how the data is compiled. Look at a problem they have. It's called block grid correction, and it has to do with drone technology taking topography of Earth. The problem is that they're still thinking Earth's a fucking ball while they're doing the stuff and trying to.
We know that for a fact. So I'm sure there's
not.
all kinds of.
If it is even close to being a ball, it's way bigger. It's way bigger than we've ever been told.
Details
because there is no curvature.
Photographs of the Earth. Brenda, I'm sure it's very technical and very detailed, and lots of smart.
You're smart. You're a smart person, right? You consider yourself smart. Let me ask you a question. Yeah, I'm going to get you to talk about something relevant.
How about you shut up?
If a camera is above you, listen. If a camera is above you,
be quiet. I'm not triggered.
I just want you to
let me ask you a question.
Very well.
Let me ask you a question, Brenda. Brenda, let me ask you a question, please. Before you continue with your nonsense, I want to ask you a question.
No,
I want to above the ground.
Everyone has to be silent. She's waving it.
He's been talking for a long time.
Camera is
I would
above
like
the
to get a
ground.
word in here.
The question,
I would like to get a word in.
The audience will get an insight to what you know. If a camera is above the ground, focus directly down.
So could I get a word in here, please?
Brenda,
you've been going for half an hour.
He's asking you a question and you won't let him finish the question.
I don't care. I'm not listening.
If the camera is pointed downward,
I just want to
get
a word in.
Here, if you're not going to listen, if all you want to do is talk, Yeah, all you want to do is come here and spew what you want to say,
I just
but you're
want
not
to have a
listening
word.
to anybody.
Just let me have a word. Just let me.
Brenda,
just
when you're
let
ready
me
to
talk.
let me know.
You need to
You
listen
want me to,
before
I
you
would
can
want me to
talk.
answer the question? Let me know.
I just want to get a word in.
Yeah, you
I
can
just
get a
wanna
word
get
in when you're
in.
asked the question.
No,
When
I'm
Yes,
not
when
going to.
First of all,
after
you
he's
don't know
answered
satellites.
the
You don't.
question.
You just said you don't know satellites. You don't know. You don't have to know. It's what you said.
Oh my God!
I just
Who
would
is
like to get a
that?
word in. That's not
All right,
me.
just
Killing my
That's
ears,
let's
you.
let
whoever that
Brenda.
is.
I
Let's let
just
Brenda
want to
get it
get a
out.
word in. I just want to talk. I just want to
Yeah,
have
she
a
won't
back and
stop when
forth.
she's triggered. She'll just keep
So
saying, I want to get a word in, 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 I want to get a word in.
All right. So what is
I
it,
just
Brenda?
want
What
to
do you
get a
want to
word.
tell us?
I
I just want to get a word in,
Okay.
see?
Go ahead. Go ahead.
She will not stop.
Jesus fucking Christ! You people are fucking children.
Oh,
Shame on you.
wow.
Shame on you.
So
Shame on
triggered.
Come on, Brenda. You have the floor. Use the floor.
Right. So the central problem is he doesn't understand what elevation is. He doesn't comprehend the idea that when you have an elevation map, it's going to give you the mean height above a given reference point, which in this case is the ocean, the sea level. And it's going to
Which
be
is flat.
It's right. We
No,
know
that's
that. You are
it's not
saying that
flat.
again.
It-
Yes, you are
holy
right, Brenda.
shit.
You are
Holy
right.
shit.
What do you want? Yes, sea level, yes. Just the height be above the sea level. And what do you mean? Of course, there is no curvature. I don't understand what you mean.
So Brenda, if a camera is pointed towards, if you had a camera in your hands and you're pointing the lens at the ground and it was perfectly at 90 degrees towards the ground, that field of view of that camera would pick up a field width of the floor. With that field width between one edge of the frame to the other edge of the frame in the photograph would represent a horizontal line. Would you agree with that?
Unbelievable.
I was gonna say if you didn't hear her talking, then something either.
Is
the
Brenda
point is
talking or I can't hear anything?
No.
Yeah, I might have to join and rejoin, or maybe just maybe
Okay.
the CPU has to reboot.
Hey, Ranty, I can come back with another demonstration in Blender regarding optics, showing you that with a 2-degree slope, an object will appear to move downward. The sun will appear to move downward past that optical limitation. Of course, it's, applying in that 2-degree slope, right?
Works.
I don't know if that matters.
Flat Earth, though.
Well, yeah, I mean, if it works, and you've got something that you want to present, absolutely, I'll show anything you got.
Okay, I got to come back because I got to switch platforms. I'm on a PC platform. I got to go back to Mac. I'll be right back.
All right. So I don't know what happened in the past 7 or 8 minutes or something, because I went downstairs to make myself a hot chocolate, came back and the chat's erupted. What went on?
Oh, that's a good idea. I'm gonna have my wife make some hot chocolate.
Do you use milk or water to make that?
I use milk.
Oh, there you go. You can't make it any other way.
So were you all being naughty whilst I was gone? Shouting at each other.
We weren't being naughty, no.
I thought it went pretty good. I thought it was pretty civil. There was no real name calling.
Okay.
But yeah, no, we have
If I
a pretty
plead the
good
fifth,
solid
do you understand
flat.
what that means?
Huh?
I said if I plead the fifth, do you understand what that means? I don't know if you guys have that over there.
Is that like you are abstaining from any kind of comment?
I don't have to speak and incriminate myself, basically.
I don't plead a fifth. I plead 1.5 liters.
We did get Brenda to admit that it's flat. The data from the elevation would create a flat graph. If you mapped it out or plotted it on a graph, it would be flat. So that was a win.
Oh, that's pretty cool.
There you
then.
go.
Yeah.
That's not a win.
So
that's
I
not
actually
a win for you.
missed Brenda admitting it was flat, right? Okay,
That's not a win for you.
So using a field of math, it looks flat, but she won't accept the
Certainly
math.
ain't a win for you.
Well, no, you just map it out using a flat base. Does it mean that the Earth itself is flat?
Yeah, but then he put a scale model showing
but then
on
it
a flat plane, and it matches reality. So then it is.
The matching is your problem.
No, it doesn't, because
Do
you
the
can,
same
you
thing,
can
Nick. Do the
measure
same thing on a with
dip of
curve.
objects.
Show us the curve. Yeah, take that elevation data and do what that guy did. Do a little scale model and show us where the curve is.
It's been done.
You don't
Objects
see
the
it.
same objects the same elevation over distance will drop.
Perspective.
Perspective doesn't make the objects at the same elevation drop.
Yeah, see, this is why they don't measure.
Further away.
Okay, so if I look down a hallway, you're telling me that if a line were painted at eye level down the length of that wall, that eventually that line is going to start to dip. That's not what we see.
Yes.
We see it go straight out into the distance.
Here's the problem.
Don't everything go, oh my God.
No. Perspective makes things above your eye level come down, and things below your eye level come up. But if something is at your eye level, it remains there. Because you can't have it both ways, where it drops but also goes up. Does that make sense?
Here's your problem.
I don't have a problem.
So,
I'm right.
Well, then let me speak.
Well, and you're a...
Oh my God.
Okay, stop talking.
So how fast does it come up to you at the shoreline? If you know how fast does the things underneath you come up to you from underneath, and how fast does it go from above?
Faster from the floor.
No, slower from the floor. Faster.
Slower from the floor? Faster from the sky. It's one way, it's one or the other, not the same.
So it's an optical thing. It just tricks your eyeball to see curvature because the top is going much faster, a plane.
Hey, Ranty, you can unmute Crow Axie.
Oh, has he finally muted himself? Right, okay. Because we're getting echoes whenever we. There you go. Can you hear? Oh, there we go. Right.
Hang on, let me say one thing real quick.
Yeah.
So this is why you don't use optics to take measurements, right? Because of the dip in the angular size reduction. So when they measure something, they do all the physical measure. Hang on, man. Hang on. You'll have your chance.
Well, you're saying things that are just wrong.
Okay, but you got to.
Yeah, but okay, you can say things
Yeah, you
that are
can't
right.
interrupt Nick. Let him finish, and then you can say, I don't agree with that or I don't agree with that. But let him finish.
Okay, keep saying things that are wrong. Go ahead.
He can. That's his prerogative. It's his turn to talk.
Mm-hmm.
Yeah, I've made my entire YouTube following on saying things that are wrong, so don't worry about it. One more thing is not going to mess anything.
That's true. What is your?
Okay, so
got
then
him
let me get it.
again.
So I got it. Yeah. So so when they measure everything, they physically measure it. Like they'll walk it, they'll look at it. And this is where the data points for the elevation and chart comes in. Now, when you start looking, right, you've left the measurements because if we measured a foot from the ground, and just kept going, right, and then we started measuring 10 feet, we would know there's a hill, right, and then we would know there's a dip. So these things would be measured. Now, when we measure this all flat, but then you walk back over the measurement, look where we already measured, see dip from optics, and then say, well, there you go. That's you see that switch you did? We already have it measured flat. That's why the data reads flat. The only time you can make a ball is when you look and then put perspective and angular size reduction into a physical thing.
Nope.
Exactly.
All wrong.
Made no sense.
But you're not a flat earther, though.
Okay.
Chris.
If all you have to say is all wrong and I'm not a flat earther, I'll rest my case on that. So, great defense you put up.
Can somebody who is genuine please explain how perspective makes everything dip? Make it go down?
That's irrelevant. That's irrelevant to the point that they don't use perspective or optics to measure. The measurements are done
we
physically.
use optics to measure all the time.
Man, come on, bro. Come on, Negatron. Come on, be a normal person. Don't interrupt me.
Well,
so
a normal person but normal about using optics.
Okay,
right?
But here's the thing. Now, why do you make now? This all comes now. This is every time I get into a conversation with anybody, it always comes down to they will interrupt me, but they have a reason.
Well, because you're just jerking people around. You're not actually.
Okay, well that's your. Okay, well I think you're a government agent. Yeah, and I think you're a government agent sent here to obfuscate the truth. And you do work for the government, right? They pay you. You're getting paid by the government, right?
Sure. Yeah.
Yeah, okay. And you're here. And why is flat Earth interest you so much if you know the Earth is a ball?
It's the curiosity behind.
Okay, but you've been here for like 6 months. Why the curiosity is done? Why do you keep interrupting? Yeah, but now you keep interrupting. Now you just need the curiosity's gone.
My answer to your
so
question,
are you here?
Right?
Yeah. Look at his little cadence. Do you hear his little cadence change? They teach this stuff. Why are you interrupting? Yeah, they do, you dumbass. They take class. I took the same stupid classes that you took that you think are working on all these people.
You took the same. So which classes did you take?
The same stupid class, the same stupid things they tell you. They're like, just remain calm. You're gonna wanna obfuscate from points. Now, you also have to use a condescending tone because that makes you seem like you have an authoritarianness to you. Right?
Well,
yeah, isn't this something
I
they
might
tell
come
you?
across the kind of saying.
Yeah, bro, because you're using
That's up to you.
tactics. I know your conversation tactics. That's what you're doing. This is why you're trying to. I can attack you, the person, and I can do better than you. You can just say, no, you're wrong, you're stupid. I can show and you admit that you work for the government, right? So I have proof of all my claims about you. You just have your personal opinions. So this is why you have to do this. So when we're measuring elevation, nobody's measuring a curved surface. Nobody does that.
You can.
It all charts out. It all charts out flat, my man. Even
right
Brendan.
the hand. Negator is CIA.
There you go. Look at that. I told you. I know, because they're here to infiltrate. Even though they're so easy to fucking spot. It's like when you see a cop at a diner eating a donut. If there's more than one donut, you know it's a cop.
The secret behind.
No, you want to see, bro. This is all about data. You're all about data. I know what the government is all about. Data. You're all about gathering data. That's why you're here. You don't think you would do something better with your Friday or Saturday night? It's Saturday night. You're here on a flat Earth surfer. Oh, because you know the Earth is a ball, though, right? No, you're on a mission. What's the mission, Negator? Tell me. Come on. You can tell me the mission. What is it? What do you hear? Well, there is no mission, right? It's just to gather data, maybe to sway the conversation in a certain direction.
Is this entertaining or no?
No, I know.
The mission is a man.
It's to not let the conversation. Get to a certain point, right? That's why you're here. You're here to make sure the conversation stays within a certain confines, right?
What happened to the conversation?
Yeah. Negator
We
fucking
got a
infected
troll
it.
here, so.
Yeah, the troll. Yeah.
When flat Earth
the one who won't talk
He's
about
got a
anything,
good
right?
point about it being a Saturday night and you're here, Neg. You're a young man. Like, why aren't you out?
I'm actually older than right the hand, but that's all right.
Ranty, I have
not
a
a young
question.
You guys are here.
Yeah.
You guys
I
are
could
here.
right hands a young man.
You guys are here.
Yeah, why would
Flat Earthers are here. Why is it?
Yeah, we're here because we believe this is true. You're here because
You're not one of them, though. You're just.
Well, it's actually
Saturday night for me. It's 9:30 Sunday morning.
Yeah, attack
when
the
flat
character when you
earthers
can't
start
do anything else.
when flat earthers start accusing ballers of being shills, it shows your true paranoia and how messed up you actually are.
Yeah.
Well, it shows how scared you are.
Well, put it this way.
It shows how scared. It shows how scared you are
Scared that we can
of
scale
everything in the
model
world.
reality and show it's on a flat plane. Yeah, that terrifies us.
Okay, so
the world against them, right?
Negator must
When
be
you think that we're paid
bloody
shills,
hell.
when you think that we're paid shills, your paranoia is
I said, why
11.
on earth would why on earth would young men on a Saturday night want to spend their time talking about something they think is stupid with people they think are stupid? Like, is your life that bad that you got nothing else to do?
Because he's interested in the debate. Perhaps
Yeah,
he's
but
got
he
a
doesn't
sick mother.
talk.
Perhaps
He doesn't have the honest conversation. He stops at certain points, and you'll ask him, "Hey, what do you mean by this?" And then instead of getting an honest answer, you get
can
stalled.
tell the ones that actually
This is why
know.
this
They will
is
tell.
this is what they're here for, bro. This is why when they're not here, you hear the conversation.
Okay, well, let's start again, guys. Let's start again. Hold on.
All you do is
Hold
like to listen
on.
to your own paranoia.
Hold on, everybody. Start. Hold on. Right, so Negator. Right, so what is it you do in this debate? I mean, do you do any experiments, tests, or what is it? What is it that you actually do, or do you just hang around these debates?
He calls that bullshit.
What do I do? Like, what's my purpose?
Well, no, I mean, what's your angle in this? I mean, what is it?
Motivation.
What is it you get out of it?
I find it extremely interesting to try to weave my way through the thought processes of folks that to the outside world look irrational or appear irrational. I think there's a little bit of a challenge to it to try to figure out why they think the way they do.
And
Oh,
you
wait a
think
second,
just
Negator, you
telling
don't
us we're
think-
wrong and not giving any evidence on your side is doing that?
Wait a sec. Page,
Wait,
Negator,
Ranty,
you
was that
actually-
a suitable response, or do you want me to keep going?
Well, no. Well, I was going to follow up basically by just saying, well, because you have been around for years, years and years and years. I mean, what makes you stay around for as long as you have? I mean, is it becoming a bit of addiction to you, or do you not see that the way that our answers have progressed recently, that might offer a challenge? Does that not make you think anything about the flat Earth, or are you still adamant it's a globe? I mean, you can see that we are doing research into this, and our research grows, yours doesn't.
I absolutely think it's an addiction, and I absolutely see it as a challenge, because every time somebody brings something new up, you have to go dig in and figure out why. And I've got an uncontrollable innate need to to correct people, and I don't know why, but this is just like this is the mountain of correction that needs to happen.
Uncontrollable. He just said uncontrollable. They have no control over
Sounds
their
like some sort of a
emotions,
condition
their
or a disorder.
feelings. They let their feelings and emotions control them, and he just admitted that.
So,
Paige is under control.
Okay, right, listen. Okay, so I've got another question. So can you ask me? I've got a personal question to ask you. So, it's a logical question. So, if you're at the beach and you're sat down on your bum and you're right next to the water, and let's suppose in your head is about 3 foot above the water, right? So you've got your feet in the water, but your head's about 3 foot above it, and you're looking out to sea, and there's a 5 foot wave out there in the distance, right, blocking your path. Do you think that 5 foot wave will stop you seeing things behind it, or partial things behind it? Or does it need to be a 200 foot wave?
Well, before I answer that, I want to answer Paige. I think that my demeanor is extremely controlled. And as far as your question, Ranty,
You were the one that said uncontrolled, Ned, not me. You said it about yourself. I didn't say it about you. You said it about yourself.
All right. Anywho, I also think, Ranty, you're not a flat earther. I think deep inside. But to answer your question,
I agree.
So what's the answer to the question, Negator?
I think
these guys
waves.
have
I think waves. Sorry, I think waves absolutely do block a line of sight of things, as long as you can, the observer, or rather the observation line from the observer to the object intersects the wave.
Okay, and do you think that like something that's in your way blocking something from you in the distance, eventually all things, if at a great enough distance, as long as that blockage was above your eye, essentially almost everything could be hidden behind that, even if it was a foot, a 1 foot higher wave than you.
I think we can mathematically determine how much that wave is going to block. I think a 1 foot wave from an observation height of lower than 1 foot will. I don't know, man. You need to give me some math so I can go work it out before I agree to something very vague.
Okay, so let's say a 5 foot wave. So let's say you're at 3 foot, and let's suppose there's an 8 foot wave out about 3/4 of a mile away. So not that far, but 3/4 of a mile away. There's an 8 foot wave. You're at 3 feet, so you've got 5 foot of blockage. How much obstruction would there be at, let's say, 20 miles? Should be pretty easy.
A flat or a globe Earth?
Well, there you go. See, do you think it exasperates the effect on a globe Earth?
I think it exaggerates, maybe? I don't know about exasperates.
Well, it exasperates me. All right, does it exaggerate it then? Because you're looking over that wave and your eyeball's looking up, whilst at the same time your globe is bending down and away.
I'll be honest. To really give you a truthful answer, I'd need to go do some calculations as far as angular size of the wave, distance, and a few other things that right this second I just don't feel like doing.
Okay.
I know that other people have done it, and I could probably dig you up some stuff. I think, hasn't this come up in the past, like with you and some other folks, as far as how much line of sight waves will block?
Yeah, people, it seems on your side of this coin, at least, on your side of the argument, don't seem to appreciate the effect that waves and shoaling and swell has. They don't seem to understand that. There's a plethora of information out there that explain the same thing, where the effects happen, how they happen. You can find the data for the regions. It's very easy to find. And yet, that is totally ignored by the globe earthers. And it is a massive problem.
No, it's been answered before, Ranty. You know that.
Yeah.
Here's one. So currently we're having this discussion with B-Ball for Life, and he's doing some observations in Hawaii, and I was able to determine that about 3/4 of a mile from his observation, we had 8-foot waves. Swell, shoaling, and the wind-driven waves, 24-mile-per-hour winds, the Beaufort scale. So all those things added into it causes obstruction. But the globers don't want to acknowledge that. They just want to say that it's a perfect proof of globe, because mathematically that works, you see. But that's excluding all the other things that went into that observation.
His height was 8 feet.
His height was not 8 feet. He even came back and said his height was 5 feet. When I pulled him up on it.
He said 8 feet this morning.
Yeah, well, he said 5 feet last night. He even sent me an image with his elevation as being
he was laying on his belly?
5 feet. He absolutely was pretty low down, yeah. He got those wave splashes in front of the camera. You can only get that right in front of the water. There was no way he'd have got that at 5 feet elevation. But his last claim was that he was at 5 feet.
Well, maybe one observation, but I tell you, he showed something with the ground is above.
But if
the
he's
water,
if he's at 5 feet,
something.
if he's at 5 feet and he's putting 5 feet in the mathematics, and that observation matches the globe Earth, without taking into account any of the other variables, the swell, etc., the wind-driven waves, all that stuff, suddenly he's not 5 feet above sea level. He's actually -3. So when you actually plug that in, the fact that he saw what he saw doesn't match the globe Earth, does it?
If it's 5 feet, then yes, I agree with you.
No, he's not 5 feet. He's about 3 feet taking the observation, and there's an 8-foot wave out in the foreground. So he's actually below the waves.
Now, how did you determine there was an 8-foot wave out in front of it?
Because we had the swell data on the day, we had the topography of the land that's in a direct line of sight, which gives the shoaling calculation. Severe slope is 1 in 10. In that particular region, it was 1 in 7. You've also got the wind-driven waves, which are 24 mile per hour winds. So on the Beaufort scale, that's an 8-foot wave. Of course, that's the total size of the wave. So the amplitude of that will be half. So the amplitude of the wind-driven wave would be 4 feet. The amplitude of the swell in that location would be at the very least 4 feet. So I was actually being generous. So we're talking a total of 8 feet for the two.
So 4-foot one, so that one crosses that one out.
I'm sorry?
Well, if he's above 4 feet, then the 4-foot example is null and void because you're going to be able to see over it. So that doesn't. Yeah, you got a foot actually.
No, you've got the swell, and then you have the wind-driven waves that are atop that. So it's a total of 8 feet of obstruction, 3/4 of a mile away. And he's claiming his elevation was 5 feet. I've been able to show that he was more likely to be about 2 or 3 feet. But even if we gave him 5 feet, he would be below those wave heights. But yet his observation matched an observer's height of 8 feet above actual sea level, not -3 feet.
Ranty, can you hear me?
Yes, I can.
Okay.
Are you not going to say something?
No, I was just having mic issues from last night. I think somebody's server muted me or something, but
I was so anticipating something.
So yeah, I mean,
Well-
do you not think that it's kind of this information should be included in these observations? I mean, I included myself with my observations. So do you not think that it should also be included in globe Earth observations when they claim it's proof of curvature?
I guess I have one thing to say. If you watch B-Ball's video as he's panning from Barber's Point over to Waikiki, in the background of Waikiki is what's called Diamond Head. It's a volcanic crater or something. It's about 700 foot tall. They say 750. And in his pan, the buildings, he zooms in and zooms out. He does really good. And he pans back and forth so you can see Diamond Head in the background and the buildings on the shoreline or the horizon line. And those buildings, he's saying that Hilton Hotel and stuff are what 200 and something foot tall. But when you can see the mountain in the background and the buildings, and then you go to your baller scale there where you stack buildings on top of each other, the Diamond Head is much taller, indicating possible compression of the buildings.
Which
Hey, Ranty, if you want to share my screen, go ahead. I have the blender up for you.
Sure. So that would actually confirm the research that Brandon Toys conducted this past week.
Yeah.
You'll have to show me the timestamp of that so that I can get some data from that.
Let me find it. And I'll
Sure.
be back.
Yeah. Is Crow watching this? Because he was interested in this dome.
So this is an entirely different example. What I've done here is just taken a sphere, I've turned it into glass, and then I just put it 6 feet height for the camera. And let's just go look through it. I'm going to show you something really interesting I find. What I'm going to do is I'm going to increase the refraction of the lens. And you're going to notice what happens in the background. So here's the lens. So that's the curved lens. You notice there's already a dip there already, right? Let's just go to the incident of refraction here, which is an option in Blender. It's off here, whatever that is. Come on. Where's the... here it is. So watch this. So the normal incident of refraction is around 130, I think, roughly. I'm going a little too crazy here. But I want you to notice the background when I increase the refraction. Watch the clouds. What does the clouds do? Are they appearing to go downward?
Yes, they do.
Yeah, they're appearing to go downward, aren't they? And that's all I'm doing is taking a lens, circular lens, turning it into glass. Okay, and I'm changing the thickness of it, or the incident of refraction, and I'm shining a camera through it right here. Very simple to do. Go to view, cameras, active camera, and I'm just zooming in, highlighting the sphere, and all I'm doing is changing the incident to refract. Look at the clouds. Look, are they shrinking in behind it?
Congratulations, you've discovered refraction.
Yes, and I'm showing you how it works.
No, it's
I'm showing how it works.
Shrink in the top.
So I'm showing you how it works in reality with refraction. So the atmosphere is like a lens. It acts like a lens, and it causes objects.
It isn't.
I believe
So
it
it
does,
causes-
Brenda.
Causes
No,
objects.
it actually isn't.
It
Well, I
causes
believe it does.
objects. I'm showing you an example here of an increased in refraction, how the clouds are appearing to move downward into the horizon line. And all I'm doing is increasing the incident of refraction. There you go, fellas. So I have another example to show you. Just let me bring it up.
Yeah, the atmosphere is not a lens.
Yes, it is, Brenda.
No, it actually isn't.
Yes, it is, Brenda.
Citation needed.
Yeah, yes, it is, Brenda. It's an atmosphere
Wha-
contains
what's your-
water.
what's
Water
your-
refracts light. Over a compounding distance of a few miles, the water will compound, causing
What's
light
your-
to refract. This is
where's your
common
citation?
sense.
Where's your
So
where's
wait,
your
just to
citation?
clarify, over a distance of 3 miles, light
your
is not.
citation?
Okay, listen, I want
Over
to
a
see your...
distance-
Hold on. I want to see your next presentation. Please. And then you can get into this with Brenda, because I think she's trying to derail this about lenses or not. I just want to see what else you produced, if that's all right.
Yeah, that's what I get paid for.
Yep, me too. I just started though, Brenda. How's medical in this business?
Medical
So,
with the CIA
can you
is
see this here, Randy?
fantastic.
Sweet.
I've just created 2 floors. One's an extension of the other floor. So
a
what
lot
I've
of
done
truth
here.
is said in jest.
Let me just go back to okay, EV. Let's just go back to rendered. So what I've emulated is the ocean here, and I've emulated the sun and the sky. Okay, and I'm just gonna bring it back here. And what
Ranty,
I've
I dropped
done.
it. I dropped it in general.
Okay.
What I've done here is I've taken the floor.
Two minute 45.
See this
start.
floor here? Can you see it? Let's just go to the transformation data. Inside the transformation data, I got an echo there.
Tony.
I raised the plane of the floor to 2 degrees. Okay. Now I've done this because in this 3D program there is no slope or angular resolution limit to the human eye. It's just using straight lines converging into a point, not at any distance based on limitations of aperture or lens size. So we know that the human eye has a 2-degree slope. This can be calculated by taking the person's height, dividing it by the tangent of 0.0217 degrees. In this case, for a 6-foot observer, you'll get the distance to the horizon line. So let's click the camera here. I'm just going to highlight the little camera, and we're going to go view it into this camera, and then we're going to see, hopefully this is, I just pulled this up. Okay, here we go. So there's the sun moving along. It's not, it is what it is. It's just a straight path orb in the sky moving away from the observer. As it moves away, it will appear to move downward based on the angle of the plane meeting the horizon. So if I take the plane and I lower it back down to 0 degrees and forget about the slope of the eye, and then I do you'll see that it moves away. It doesn't sink below anything.
Until
So
hold on.
The point is that the human eye has an angular limit of 2 degrees. We raise the floor 2 degrees in the program, it will appear to move downward. Because there is a diffraction point, an angular point where light becomes too acute to resolve, and it creates a vanishing line, a vanishing point. Euclid calls it. Euclid says that they are.
How come this doesn't show reality?
Right, I'm going to have
Euclid says they are convergent of light that has no magnitude. So it means it's not measurable, quantifiable. It's an optical effect. I have this crazy repeat, man.
Yeah, that's fine. I'm just having to mute it. Everyone seems to be jumping in and trying to ask questions when you're still presenting, and I've told them not to bother doing that, and it's really pissing me off. I'll take you off serving mute in a minute or so. I'll let you finish up your presentation.
So anyway, I'm just saying that to count for the slope of the human eye, if you do so in this program, by raising the plane up 2 degrees, and if the object moves past it far enough, it will appear to move downward just like in reality. Okay?
But here's the one other thing. You see what you're looking at here, and this has been demonstrated with many different observations, including Wolfie, etc. And we all see this. Is that very last?
I'm just listening.
The very last part, probably the last 10 minutes or so before the sun disappears, you actually start to lose the definition of the sun. So it seems to, when you got your filter on, it seems to shrink and shrink and shrink and then disappear. So is it the atmosphere that's causing that at the very low levels?
This is not adding any atmosphere in it. So what is happening is the glow is maintaining the relative size of the sun. Now, what I've done, I haven't released any of this stuff yet because it's so, man, when you start getting into this and you just want to get really clean data, it actually takes especially when you don't live around a sunny place all the time. Basically, putting a solar filter on a 50 mil lens, setting it up, it will appear to show the sun reduce in size as it moves away. With my experience, but when you zoom in, you have that optical compression. You don't get that detail. I don't know what you're referring to. Did I go off on a tangent there?
Could you just put an atmosphere at some point? Can you get around to putting an atmosphere in and a little bit of downward refraction? So and refraction that pulls the light down on a flat plane, not refraction.
What I was going to do is I can add a lens in before to simulate it But yeah, I think because I can't, my computer's not that powerful for that kind of effect, like adding in that atmosphere and all that stuff. I'd seriously need a more powerful machine. But I wanted to show that example of the lens, showing you in real time that if the intensity of the refraction is increased, it will actually appear to move stuff downward. I just demonstrated it with a quick example. Light refraction shows that stuff will get squished downward. And then with this example, I've shown you that, yes, with the rising of the floor to a 2 degree, you will have an angular limit cutoff. I mean, it is what it is, right? It's an example that anybody can do quickly with the assumption of perspective is caused by the eye and not physical arc in the curvature calculators. Right?
Cool stuff. Right, I'm going to take these guys off mute now, so if they want to chip in, it's up to them. But I think Crow's got a couple of questions for you.
I'm going to try to find another one too. Give me a second.
How come this doesn't correspond to what we see in reality?
Well, first of all, it's just a quick example of how objects can disappear bottom up through the angular limit. This is just showing you a physical object. The sun is not a physical object. It's refracted and an apparent position to us. But it's just showing you that if you account for the angular slope, which is in every video game programming, Oculus, they all program for the slope of the human eye. It gives you the 3D perception, depth of field. It's very important to understand. Perspective, essentially, which is caused by the lens and the angular relation of the object to the lens going through the aperture of your eye. So, of course, you have to assume these factors to present the results. Like one of the next examples I'm going to do is try to put that particular object of light on a big, larger sphere above, and have an observer. Well, I'm not presupposing I have this fucking echo. It's crazy to talk to. I'm not presupposing the slope of the eye. That's a fact. I'm not presupposing the math. The math is calculable without curvature formulas based on the angular resolution. So I'm not presupposing anything. I'm applying the knowledge into the observation and showing when I apply the knowledge, I get the result. Now, can I apply everything? No, of course not. But can I apply angles and distance? Yeah, I can.
Is the plane of the sea in this example, is that flat?
So it's sloped 2 degree based on the optical compression of the human eye. So it's basically
so it's not
sloped 2 degree. It's flat.
So that's how you're faking. That's how you're faking the sunset, then, isn't it?
No, it's showing you the slope of the angular.
How you're faking. That's how you're faking the sunset.
No, I'm not.
You're sloping. You're sloping the.
If I was to fake it, I wouldn't tell you about the slope. I wouldn't tell you that I rose the ground 2 degrees, moron.
Yeah,
so
but
the point is, I tell you to raise. So in your Earth curvature calculators, Brenda, there's an arc. The arc is the position from the observer to the horizon point. Can you tell me what causes that arc?
That would be the curvature of the Earth, wouldn't it?
Okay. So when we look down a hallway, there's a rising of the ground there. Where's the Earth curve there?
Hallways are flat.
Okay, there you go. You just got your answer. The guy's a moron, and you know what?
How is
Brenda,
that an answer? You
just said the Earth. You just said the arc was caused by the Earth curvature, but then the hallway is caused because it's flat. I don't need to debate you, dude. You are just a pathetic weirdo. You are the epitome of the Baphomet in the world. You are the shining crown of the Baphomet, dude.
Yeah,
that's all you are. You're a shining crown of the Baphomet.
What you have here is a plane,
you're a grotto.
And you're faking sunsets.
You're a grotto. No, I'm not. I'm adding the slope.
You're faking sunsets.
The eye. What I'm I'm not faking anything. I'm not lying about anything. I'm showing you applying what we know to the observation. You are an example of why humanity is failing, Brenda. You, right here, right now, you are the example.
Fantastic.
Shame on you.
Yeah,
Shame on
he's
you.
right.
I
Yeah,
have a
shame
question
on you,
about
Brenda.
this model. What's the ratio of the height of that whatever
So
object?
they're
you
irrelevant.
have?
You can make it as height, distance, and size are arbitrary in 3D program, bro. You can make the plane as big, as small as you want. It will be still arbitrary. Okay.
Yes, that's
It's
why
a
I
3D
asked about the ratio That's why I asked about the ratio.
The ratio is irrelevant. You can make it whatever size you want.
The ratio is very relevant. What are you talking about?
I can zoom in to 1 millimeter, put a camera up and do the same thing. It's a 3D program. They're arbitrary. The sizes are arbitrary. That's just a fact.
Well, okay, then let me tell you why the sun is setting in this model. The sun is setting because you had it set at altitude of 6 feet or 18 feet.
Would you like me to make it higher? It would just take farther to go in the distance. The point is, this 3D animation program won't give you that resolution detail if it's that high, that far away. It doesn't
That's
emulate.
why I said go for
it
ratio.
doesn't emulate reality, dude. It's a 3D program. So
Then
what
don't
I'm
show
showing
it if it
you,
doesn't emulate anything.
what I'm showing to you is that the object will get cut off by angles. That's it. By ramping up the floor to the 2
It
degrees.
gets cut off by the end of the
Look at
plane, which is elevated off of flat.
Listen, gentlemen, there is an apparent junction of the sky and ground. It's not caused by Earth curve. It's caused by the perspective, the vision of the human eye.
Perspective doesn't cause anything to be
This
obstructed.
is a junction. This is a junction. It's an apparent convergence of parallel lines. They don't converge. There's no magnitude to them. There's nothing measurable. It's an optical effect. The 3D program doesn't have the aperture of the eye in mind to cause the diffraction point at 3 miles. Because position,
may I
elevation,
speak- may I
and
speak for a
sizes
second?
are arbitrary. Thank you.
So may I speak for a second? So what you have here is you have a plane which is tilted, and you have a sun which is only 6 feet above that plane, and then it gets smaller and disappears behind the plane because the upper edge, that edge is tilted off of flat.
Yes, because he's showing you what the eyes would normally do, which this program doesn't take into account.
You're claiming that the arc is caused by Earth curve. I'm claiming it's caused by perspective. Do you see the difference there, Brenda? What I'm doing in the demonstration,
This isn't perspective. It's
I'm
not
showing you-
perspective.
Yes, he's adding it in.
I'm adding
That's
in.
why
it-
he tilts it down.
Right, guys, I'm going to wrap it up. Doesn't seem to be anybody in the chat enjoying these streams recently, so yeah, I'll just call it a day and think about doing some more shows maybe next week. Right, guys, thank you everybody for stopping by. Hope you enjoyed that all. I'll record this show going forward for the after show, release that sometime, and yeah, we'll just take it from there, guys. So thanks everybody for tuning in, and I'll see you all in the next one.